Hello guys, welcome to ACE Online. In this video, we are presenting video solutions for pre-GATE 2025 Mechanical Engineering exam. As you know, the real exam is having a jumbled questions, which means that the first question is from strength of material, second question is from heat transfer, third question is from thermal. Like that we are having a jumbled questions. But to make you understand the concepts easily, we have organized the questions subject wise. So we are providing the solution subject wise so that you can understand the concepts very easily, guys. And I would like to say that due to popular demand from the students, we are happy to announce that we are conducting one more free mock test on 26th January 2025. For details, guys, you can scan this QR code for registration. I hope you utilize this opportunity well and assess your score, assess your weak points, guys. It is going to help with your preparation. Finally, guys, wish you all the best for your preparation. Thank you, guys. Let's check this question, guys. The figure shows an idealized plane stress. The magnitude of the force produced in the member CD is how much, guys? Very simple. If I just check it, if you observe carefully. Check the zero force members. At this location, two are parallel, thrown at an angle, guys. The force in this member must be equal to 0, guys. Yes or no? Then, if I draw a BD at this location, guys, this is the F of CD. This is the F of AC. This is the F of EC, guys. Again, the force in this member also equal to 0. Why it is, guys? Same thing, guys. If three links are meeting at a joint, out of these three, two are collinear, third one is at an angle, so the force in this member must be equal to 0. The answer equal to how much, guys? The force in this 0 is 0 newtons, guys. Next, a uniform rod of mass M and length L is kept vertically with a lower end clamped, which means that this is the lower end which is clamped, which is clamped. The length is L itself, guys. Okay, it is slightly pushed to fall it down, which means that simple like slightly push it to fall it down like this. Simple logic, earlier it was like this itself. Now slightly push it to fall it down like this. Then under the gravity, what is the linear speed when the rod is passing through its lowest position? Which means what is the linear speed he is asking, velocity is asking, linear speed. How can you say, guys? Assume this is having center of mass at this location. This is center of mass. Whenever it is coming here, it is coming here, it is coming here, it is coming here, guys. Now the link is turning. Second position is like this. This is the second position of lowest position. This is the second position, guys. Then he's asking with what velocity it can able to go here. With what velocity I can able to go here, guys. Now what is this length, guys? L by 2. This length also equal to how much, guys? L by 2 only, because till the center of mass, center of mass location. Then definitely, guys, here no loss of energy, guys. Energy is constant, I can say. So I assume that this is the first position. This is the second position. This is the second position. I can write energy at the first position must be equal to energy at the second position, guys. So energy at the first position, so I can write here velocity equal to 0, but having some potential energy. I am assuming second position as the reference. If I take this is the reference, guys, then what is the potential energy of this one, guys? I can write mg, because weight will be having, guys, mg will be present. Mg into h. H means L, guys. Mg into L is energy at the first position. Second position, guys, exactly. So center of mass is lying in the same location, so it doesn't have any potential energy, but having kinetic energy, guys. How much, half into, yes, half into, I can write is a rotating member, half into I omega square. It is a rotating member itself, half into I omega square, guys. But he's asking what exactly V. So how I can able to say what the relation V and omega, V equal to R omega square. V equal to how much, guys? R omega square. Now substitute half into I means how much, guys? Formula ml square by 3. ml square by 3. So V equal to R omega. So omega equal to how much, guys? V by R. I can write V square by R. R how much guys? Center of mass ka. L by 2 na I can write it. R square means L square into 4 I am going to get that equal to mgl. Now if you observe carefully guys, getting cancelled guys. 1L getting R I can write L square getting cancelled. So this L will be present. This is 2 times I am going to get guys. So I am going to get approximately guys V square equal to 3 by 2 GL. So V equal to square root of 1.5 times of GL. The answer is option D is the correct answer guys. Okay, I hope this is clear. Okay guys, let's see this question. The slenderness ratio of 1 meter column with both ends fixed. Here keyword is what guys? Both ends fixed. If its cross section is a square of side 10 centimeters, then what is slenderness ratio equal to? How much is asking guys? How can we find out what is the slenderness ratio formula? First of all, lambda equal to effective length of the column by least radius of gyration guys. First, what is the effective length here? Effective length equal to how much guys? The length of the column by 2. Yes or no? Why length of the column by 2? Because the both ends are fixed. So I can write L equal to 1 meter and I can write 0.5 meters I am going to get. Next, K. So K means it should be K minimum. It should be minimum radius of gyration. It should be minimum radius of gyration. How can you find out this K minimum guys? You know this formula. I equal to AK square. Okay, I formula how much guys? Before 4 by 12 because it is a square cross section. A equal to how much guys? Anyone? A equal to B square because again it is square cross section. So K equal to how much I am going to get guys? I am going to get B by root to 12. Yes or I can write B by, I can write down guys 4 into 3 not 2 root 3 I can able to say. Now just substitute guys. Lambda equal to LE 0.5 by B. B how much guys here? B equal to 10 centimeter. Now it's 0.1 meter guys I can write. 0.1 meter by 2 means I am going to get 2 into root 3 guys. So I can write 5 by 1 I can write 10 into root 3. So approximately 17.3 you will get guys. You can make approximate answer as a 17 itself. Clear everyone? Yes. Next, coming to the next question guys. Let's see this question. The shape of the elastic curve in the segment BC is asking in this segment BC for the frame shown in the figure is how much guys? To find out the shape, we need to find out the radius of curvature. How can you find out the radius of curvature guys? Just transfer this force here. If I transfer the force here, this is the P here, this is also P here guys. 1 second, yes. This will give the couple like this. This will give the couple like this. Getting us, this will give the couple like this. This will give the couple like this. Now, axial force doesn't have any effect on the elastic curve, guys. But if we take the momentum, if you take the moment, guys, this is the moment M. This is the moment M. If you observe carefully, sir, this M moment everywhere constant or not, sir? If the moment is constant, you know this formula, guys. E by R, M by I, 1 by R equal to M by EI, guys. If you observe carefully, sir, moment is constant, but then R equal to constant. So radius of curvature is constant for only for what kind of curves, guys? Circular curve only. I can write down, guys. Sorry, it is going to bend like this. It is going to bend like this, guys. It is going to have a circular curve itself. R equal to constant. The answer is option B, guys. Hope this is clear. Okay, let's see this question, guys. The normal stress of equal magnitude 100 megapascal but of opposite signs act at a point of a strained material is in a perpendicular direction, guys, which means that there are two planes are there. One is normal stress of equal magnitude. One is sigma this side, guys, another is sigma this side, guys. one is both of equal magnitude. So this value equal how much is given, guys? 100 megapascal is given. Then magnitude of the resultant stress, asking magnitude of the resultant stress acting on a plane inclined at 22.5 degrees to the applied stress is how much, guys? Here this is applied stress by default, guys. Applied stress means his intention is applied stress plane. What is a plane, guys? Here what is applied stress plane? This is the applied stress plane, amma. So for this applied stress plane is acting how much, guys? How much angle? 22.5 degrees. In this 22.5 degrees plane, how much is the value of resultant stress he's asking? Let me give you, guys. Assume this is the plane, amma. This is the angle. Theta equal to how much, guys? I can write theta equal to plus 22.5. My task is to find out what is the normal stress sigma theta, what is the shear stress tau theta, then resultant stress equal to how much, guys? R theta. I can able to write square root of sigma theta whole square plus tau theta whole square. This is about the R theta, guys. Clear or not, sir? Now if you observe carefully, sir, now if you observe, guys, I am going to get sigma x equal to how much? Sigma y equal to how much, guys? Minus sigma, guys. Sigma x equal to sigma y equal to minus sigma, guys. Next, theta equal to how much? 22.5. Next, tau xy how much, amma? Tau xy equal to 0, guys. Then I can write sigma theta formula. Sigma theta equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta, guys. If you observe carefully, sir, this value will be 0. Why? Because sigma minus sigma. And this value, how much I am going to get, guys? Sigma x minus of minus sigma, I am going to get 2 sigma by 2. I am going to sigma cos 2 theta means cos 45, guys. Cos 45 means 1 by root 2, sigma root 2. This value will be 0. So I got sigma theta equal to sigma by root 2, guys. Now coming to tau theta, guys. Tau theta formula equal how much, guys? Minus of sigma x minus sigma y by 2 sin 2 theta plus tau xy cos 2 theta. This will be 0. And sin 2 theta means sin 45 degrees equal to 1 by root 2 itself minus of sigma x minus sigma y by 2 minus of sigma x minus same thing, sigma minus of minus sigma plus sigma I am going to get 2 sigma by 2 same thing, sigma itself minus sigma I am going to get. So tau theta equal how much, guys? Minus sigma by root 2 I am going to get, guys. Now if you substitute here, resultant stress on the plane equal to square root of sigma by root 2 whole square plus minus sigma by root 2 whole square. Root 2 whole square, guys. Now, how much I am going to get, guys? I can write, take sigma square common and sigma I am going to get, guys. Square root of 1 by 2 plus 1 by 2 means how much is coming, root over 1. How much is coming as answer equal to sigma itself. Sigma means how much is answer, 100 megapascal. Okay, I hope this is clear. Okay, guys, let's check this question. A stepped bar ABC of total length 2L carries an axial load 2P at the B. Then displacement at B equal to how much is asking, guys. See, observe carefully, sir. To find out this displacement here, first we need to find out the support reactions. When you try to apply the force here, this side reaction is here, I can write RA. This side reaction is this side, RC. You can take it ulta also, guys. If you take a wrong answer, because when you try to push it, reaction will be coming this side itself. Even if you keep it this side also, no problem. You get the negative answer. That's it. Okay. Now observe carefully, sir. Now, all left side force must be equal to right side force. So I can simply able to say RA plus RC must be equal to 2P. Second thing, guys, compatibility equation. It is a statically indeterminate structure. What is the compatibility equation, guys? Deflection of AC must be equal to 0 because between AC deformation equal to 0 because both are fixed ends itself, guys. So I can write deflection of AB plus deflection of BC equal to 0. Yes or no? So I can say P1 delta L1 plus delta L2 equal to 0. I can write P1 L1 by A1 E1 plus P2 L2 by A2 E2 equal to 0. Now, what is the P1, guys? How can you find out the P1? Keep the hand in the middle of the bar. Look at only one direction. Either this side or this side, you get the same answer, guys. I'm looking at only this side, amma. So, P1 equal how much, guys? RA. The length of the first bar, how much, guys? L by, iska how much, guys? 2AE. Plus. Second thing, guys, P2 how much am I even? Keep the hand over here. Look at only this side, guys. RA minus 2P. Keep the hand here. RA minus 2P, guys. RA minus 2P. Length is how much, guys? Same L by AE equal to 0. Now, L getting cancelled, AE getting cancelled. How much is coming, guys, here? RA. Yes, to multiply, guys. 2RA minus 4P equal to 0, guys. How much is coming from this? I can write, guys, 4P by 3. RA equal to 4P by 3, guys. Now, deformation of B with respect to A must be equal to B with respect to A. He's asking deflection of B equal to how much, guys? Same thing. P1 L1 by A1 E1. P1 L1 by A1 E1 is a deformation, guys. What is the P1 number? Only RA is present. RA is how much, amma? What is the value of RA, guys? I can directly write 4P by 3 into L is L by AE, guys. How much is coming, amma? 4 by 3 into PL by EA. 4 by 3 into, sorry, guys, RA equal to, yeah, AE, but here mistake is how much, guys? Here it should be 2AE, na? It's 2AE itself, guys, coming 2AE, guys. So 2 getting cancelled. How much is coming here? 2PL by 3EA. The answer is what exactly? Option B is the right answer. I hope this is clear, guys. Okay, guys, let's see this question. A beam of length L shown in the figure. If spring carries 1/3 of the total load, what is the spring stiffness equal to how much, guys? But a small correction in this typo error, amma. All are ulta, amma. It should be 386 EI by 7L cube. Please rectify it, guys. Here also how much? 384 EI by 5L cube, like the answer is going to be coming, guys. 1158 EI by 7L cube, like that. Okay, but which one is the correct answer, guys? For this, you have to understand, you have to draw the free body diagram for this. First, what is the free body diagram for this, amma? You are drawing a simply supported beam with UDL. Next, center I am having a spring force. Fs will be there, guys. Spring force, Fs will be there. Now, on the springs, having this one itself, guys, Fs itself, this is a typical free body diagram. But it's clearly given that the spring carries how much, guys? 1/3 of the total load, guys, which means that total load how much, amma? W into L is the total load. Fs equal to how much, guys? 1/3. W L by 3 it is going to carry, amma. Then what is the stiffness of the spring equal to how much is asking? What is the stiffness of the spring equal to how much, guys? How can we find out? Listen carefully, guys. How can we find out, amma? First, for the comparability equation here, I can write deflection at the midpoint. Deflection at the midpoint equal to deformation in the spring. Midpoint equal to deformation in the spring, guys. What is the deflection at the midpoint, guys? In the C's, because it is going to deform like this. So whatever mid deflection will be compressed by the spring itself, guys. Deflection at the midpoint. So at the midpoint, two loads are acting. One is UDL, one is spring force Fs. So I can, due to UDL formula, how much, guys? 5 by 384 WL power 4 by EI. Now this Fs will give you upward deflection. How much, guys? Minus Fs into L cube by 3EI must be equal deflection of the spring. What is deflection of the spring, guys? You know that, guys. Spring force, if I know, F equal to in delta, na? Delta equal to F by K. So I can write Fs by K of the spring. K of the spring, guys. Now substitute. Fs equal to guys WL by 3. So how much I am going to get, guys? 5 by 384 WL power 4 by EI minus Fs equal to WL by 3, guys. So WL by 3 into L cube. WL power 4 I am going to get, 48, 48 into 48 EI. Simply support beam, it should be 48, guys, equal to Fs means how much am I again? WL by 3 into K of the spring, guys. Just simplify, guys. One L getting cancelled everywhere. You get the K of the spring equal to approximately, guys, 386. Yes, 386 EI by L cube, 7L cube I am going to get, guys. The answer is option A is the correct answer. I hope this is clear.
Hello students, I welcome you from ACE Academy for Pre-GATE 2025 Mechanical Engineering FM subject. Let us look at the first question. This is a 1-mark question, very basic theoretical question. The question is saying, for a steady laminar incompressible boundary layer flow over a sharp-edged flat plate at zero incidence. So standard LBL condition over a plate with zero incidence. Which one of the following options is correct? He's asking. Okay. So recall, whenever boundary layer formation is there, let us say something like this you are going to have. This is a plate you are having, and this is a formation of boundary layer you are having. Okay. Let us look at each statement and check whether they are correct or not. The first statement over here says the edge of the boundary layer is a streamline. This edge over here is a streamline. This is a wrong statement. It is a wrong statement. As a matter of fact, the streamline is a displaced streamline you are going to have above over here. This in no way is representing the streamline. Okay. And the displaced streamline is getting displaced by a distance of delta star, that is called as displacement thickness. So statement A is wrong. Okay. Moving further, the edge of boundary layer is a path line. Again, that is wrong because a single particle is not tracing this particular path. As a matter of fact, velocities are not tangential at any point over here. Velocities are still in horizontal axis only. That is why both A and B are wrong. Recall, streamlines and path lines are such that the velocity is supposed to be tangential, which is getting violated over here. This is wrong. Now look at statement C. The skin friction coefficient, which we call as CF, decreases as the distance from the leading edge increases, correct? As a matter of fact, CF is proportional to 1 by root over of REX, which implies CF is proportional to 1 by root over of X. And this is a very reason why even wall shear stress is proportional to 1 by root over of X. Okay. So as X increases, you see, as a distance from leading edge increase means X is increasing. Skin friction coefficient decrease means CF is decreasing. Perfectly correct. Statement C over here is correct. Now we have to look at statement D just in case it is having multiple answers correct. So statement D over here is saying the skin friction coefficient remains constant all along the plate. It is violating statement C. That is wrong. So the only correct answer over here is statement C. Option C alone is correct over here. I hope this is clear to all of you. Moving further, look at this question now. This is a numerical but still worth 1 mark only. The question is saying if P inlet is equal to 1.2 Pascal and P outlet is equal to 1 Pascal, are the average pressures at inlet and outlet respectively for a fully developed flow inside a channel having a height of 50 centimeter. Let us stop at this point and write the given data. Delta P over here is equal to how much? It is equal to, delta P is drop in pressure. It is P in minus P out, that is equal to 0.2 Pascal. Now, always make it a habit to write every given data in SI units. People keep asking me that they happen to commit silly mistakes in units and all. First of all, there are no silly mistakes. Mistakes are mistakes. Okay? If you want to avoid the mistakes in units, the best way is to write everything in SI units and calculate correspondingly everything in SI units only. Delta P is 0.2 Pascal having a channel height of, that means the width between the plates we represent by B, that is equal to 0.5 meter. Then the absolute value of average shear stress acting on the walls of the channel of length 5 meter is how much? Length is equal to how much? 5 meter, he is saying. Length is equal to 5 meter. Now recall, average shear stress acting at the wall. Wall shear stress tau naught in the case of laminar flow between plates is equal to how much? It is equal to minus dP by dx multiplied to B by 2. Now minus dP by dx is as well equal to delta P by L. So delta P by L means how much? Delta P by L is 0.2 divided by L over here is equal to 5 multiplied to B over here is equal to 0.5 divided by 2. This is the value we are having. Now if you see 0.2 into 0.5 will give you how much? It will give you 0.1. 0.1 divided by 10 is equal to 0.01. It is going to be equal to 0.01 Pascal. This is the value of wall shear stress. Now he's asking the answer in Pascal. 0.01 is option C over here. The correct answer is option C. I hope this is clear to all of you. Very basic formula based question you are having. Let us, I hope you can see a solution. If you wish, you can pause. Okay. Let us now move further to the next question. Look at this question. This is from fluid kinematics. It is dealing with the concept of acceleration. The question is saying the velocity components in Cartesian coordinates in a 2D incompressible flow are u is equal to e power y cos x, v is equal to e power y sin x. The magnitude of total acceleration at point -1, 1 is how much? Let us start. This is a good question. It will be a lengthy question. It is worth 2 marks. U is equal to e power y cos x. U is equal to e power y cos x. Let us find out the value of ax. The value of ax is equal to, it will have 4 terms. 1 temporal, 3 convective. Okay. But I see it is a function only of x and y. So I'll write only the convective parts corresponding to x and y. It is u dou u by dou x plus v dou u by dou y. Achha, let me do one more thing. Let me also write the value of v. V is equal to e power y sin x. E power y sin x. Okay. Now, basic differentiation is required right now. Let us see. The value of u we know is equal to e power y cos x multiplied to, what is dou u by dou x equal to? Dou u by dou x is equal to, if you differentiate cos x, you are going to get over here minus sin x. So you are going to get e power y into minus sin x minus sin x plus v is equal to how much? E power y sin x Dou u by dou y is equal to how much? Dou u by dou y is equal to e power y cos x. It will come out to be e power y cos x. Now if you check this thing, it is going to be e power y into e power y is e power 2y. Cos x into minus sin x is minus cos x sin x. Again over here e power 2y plus e power 2y Cos x into sin x is again cos x sin x. I hope it is clear till here. Now, if you check this value, ax will come out to be 0 regardless of the space location. Whether it is 1, 1, 2, 2, any space location, this value has to be equal to how much? 0. Ax is equal to 0. Now, I have to identify the value of ay. To identify the value of ay, let me again write down u is e power y cos x. U is equal to e power y cos x. V is equal to e power y sin x. E power y sin x. The value of ay is equal to how much? Ay is equal to u into dou v by dou x plus v into dou v by dou y. Now u is equal to how much over here? E power y cos x multiplied to dou v by dou x is equal to e power y cos x. I hope you understand. Sin x differential with respect to x is cos x. Plus v is equal to e power y sin x multiplied to dou v by dou y is equal to e power y sin x. E power y sin x. This is what I'm having. Now from here I get e power 2y common to cos square x plus sin square x plus sin square x. Now cos square x plus sin square x is equal to 1. We know this trigonometric condition. So we get a y is equal to how much? E power 2y. So that means since ax is equal to 0, only ay is present. That means the value of magnitude of a is also equal to how much? E power 2y. Now all I have to do is put in the value of y to get the answer. The question is asked at x is equal to -1 and y equal to 1. So I'll get therefore at -1, 1 magnitude of a is equal to how much? E power 2. This is the answer. E square is the answer. So let us see. E square is present over here. Option D would be correct. Option D is the answer over here. Okay. If you want, you can pause. This is the solution for AX. You can pause if you want. This is a solution for AY, and along with that, it is also a solution for acceleration magnitude E square. I hope this is clear here to all of you. Let us look at the next question. This question is coming from the concept of fluid dynamics, having impact of jets topic. The question is saying a jet of diameter 20 mm and velocity 6 meter per second coming out of a water tank standing on a frictionless cart hits a vane and gets deflected at an angle of 45 degrees as shown in the figure below. The density of water is 1000 kg per meter cube. Neglect all minor and viscous losses. If the cart remains stationary, the magnitude of tension in the supporting spring connected to the wall is equal to how many Newton? This is a question asked. So let me take the control volume over here. This will be the control volume I'm having. This over here is a control volume I'm having. Okay. Now for this control volume, if you observe, there is no influx present, only efflux is present. No influx, only efflux. So if I draw the FBD of the system, the FBD of the system is this, let us say, I'm having something like this. There is some tension T over here. There is some velocity of exit V over here. Okay, velocity of exit V over here. This is a free body diagram, let us say. Now I can write over here sigma Fx has to be equal to how much? It has to be equal to m dot into velocity in x efflux minus m dot into velocity in x influx. This is the value of sigma fx. There is no influx present right now over here. Since there is no influx present over here, this comes out to be equal to 0. Sigma fx over here is equal to tension. Tension is equal to m dot into velocity in x at the efflux. Now, if you observe over here, m dot will be equal to rho av and velocity in x is equal to v cos 45. So, m dot is equal to how much? Rho av and velocity in x is equal to how much? V cos of 45 degrees. So this will be equal to rho into area is equal to how much? It is equal to pi d square by 4 multiplied to V into V is equal to V square multiplied to cos of 45. अब देखिए, he is asking the value in Newton, SI units. I'll write everything in SI units over here. ठीक है? This is D naught over here, mind you. Diameter of the jet. Now it is water. Water is coming out. So therefore rho is equal to 1000 multiplied to pi. Diameter is given as how much? 20 mm, that is equal to 0.02 meter. So 0.02 square. Velocity is equal to 6. So 6 square whole divided by 4 and cos 45 is 1 by root 2. Therefore this is the value you are having. And if we calculate this particular value, if we calculate this value, let us see, 1000 pi into 0.02 square into 6 square divided by 4 root 2. I am getting the answer as 7.997. I am getting this value as 7.997 Newton, which you can approximate as 8 Newton. Okay. So the best answer over here would be equal to 8 Newton. 1 second. The answer over here, the answer over here is equal to 8 Newton would be the best answer. I hope this is clear. If you wish, you can look at the solution and you can pause the solution over here. 8 Newton is the answer. Moving further to the next question, look at this thing. This is coming from the concept of Bernoulli equation. The question is saying a centrifugal pump is used to pump water, density is 1000 kg per meter cube, from an inlet pressure of 10 power 5 Pascal to an exit pressure of 2 into 10 power 5 Pascal. The exit is at an elevation of 10 meter above the pump. The average velocity of the fluid is 10 meter per second. The cross-sectional area of the pipes at the pump inlet and outlet is 10 power minus 3 meters square. Acceleration due to gravity is 10 meter per second square. Neglecting losses in the system, the power in watts, he wants the answer in watts over here. The power SI units delivered by the pump is equal to how much? Okay. Now let us look at the important data. This is density, this is inlet pressure, this is exit pressure. The exit is at an elevation of 10 meter above the pump. The velocity is equal to 10. Acceleration due to gravity is also 10 SI units. The area of the pipe is equal to 10 power minus 3. I'm assuming calculator will not be that much important in solving this question because the numbers seem to be quite easy. Okay. Let us first of all draw a diagram. Suppose this is section 1, this over here is pump, this is section 2. Okay. Section 1, the pressure P1 over here is equal to 10 power 5 Pascal according to what is given, and P2 is equal to 2 into 10 power 5 Pascal. V1 is equal to V2 is equal to 10 meter per second. Okay, a1 is equal to a2 is equal to 10 power minus 3 meter square, 10 power minus 3 meter square. G equal 10 meter per second square. Acha. Exit is 10 meter above. That means Z1 I can take is equal to 0 and the value of Z2 is equal to 10 meter. Now that I have this thing, I can write the equation P1 by gamma plus V1 square divided by 2G plus Z1 is equal to how much? P2 by gamma plus V2 square by 2G plus Z2. अब देखिए, he said don't consider the losses. So I'm going to consider only the pump. So I'll write minus HP. I realize over here that the velocity heads are identical. So therefore velocity heads cancel off. The value of HP will come out to be equal to how much? HP comes out to be equal to P2 minus P1 divided by gamma plus Z2 minus Z1. Now P2 minus P1 is equal to 10 power 5. Gamma is equal to 10 power 4. So 10 power 5. How am I saying gamma is 10 power 4? Because density is 1000, G is 10. So this comes out to be 10 power 4. Plus Z2 minus Z1 is equal to 10. This value comes out to be 20 meter of water. Remember, head is never mentioned only in meter. You should also mention the fluid involved. So the value of HP is equal to 20 meter of water. Now that you have identified the value of HP, you can say pumping power is equal to rho Q G H. Which H? HP. So this comes out to be equal to how much? Rho A V G HP. Because Q is equal to how much? Area into velocity. Now rho over here is equal to how much? Rho over here is equal to 1000. Area is equal to 10 power minus 3. Both cancel off. Velocity 10, G 10, HP 20. Velocity is 10 meter per second. G is 10 meter per second square and HP is 20. So the value of pumping power, everything I have written in SI units, I will get the answer also in SI units. It comes out to be equal to 2000 watts. Now since the answer is asked in watts, we have attained whatever is required. The pumping power required over here is 2000 watt. So these were the questions in fluid mechanics for mechanical engineering pre-gate. If you still have any doubts, please contact us. We'll be very happy to help you. Thank you.
This question is from theory of machine and topic would be vibrations. A spring mass damper system having an undamped natural frequency. Undamped natural frequency is 25 radian per second, is subjected to forced vibration. If the damping is provided to the system is 50% of the critical damping, so this is straight away, this value is nothing but zeta, that is damping ratio. Okay, then the frequency at which the peak value of amplitude occurs is dash radian per second. So there is a formula where we calculate this frequency at which the peak occurs. So that is from the relation, that is, I hope you remember this, dynamic magnification factor is equal to 1 by 1 minus r square whole square plus 2 zeta r whole square raised to the power of 0.5. So this is the relation, and if you observe here, the most influential variable in this expression is r actually. Okay, zeta is going to be less than 1, and since the system is under damped, the values of r will be changing from 0 to infinity. Okay, so values of r is going to change, so the r will be most influential variable. So if you differentiate this expression with respect to r, we get r is equal to 1 minus 2 times of zeta square under root. If we perform the differentiation for this expression, we will be getting this as an answer. So R is nothing but the frequency ratio, which we can write it as omega is equal to omega n times of root over 1 minus 2 zeta square. So this is the relation we are supposed to make use of it. Okay, so this is when DMF or D by, that is this expression will be getting when we differentiate D of DMF by dr is equal to 0. Okay, if we differentiate it, we'll be getting this as a result. So this is a standard formula, I mean you can remember it, and since the value of zeta is given and natural frequency is 25, we need to just put in the values. So this is omega p, because we are supposed to find at which the DMF is maximum. In short, if DMF is nothing but x, that is amplitude of forced vibration by static deflection. So static deflection is going to be a constant value and amplitude of forced vibration is going to be changing. So omega p, which is nothing but the frequency at which peak amplitude of forced vibration occurs, that is 25 into root over 1 minus 2 times of zeta square. Zeta here is equal to 0.5. Zeta is equal to 0.5. So zeta square will be 1 by 4. Okay, that is 0.25. So 2 ones and this is 2 2. So this is 1 by 2. So 1 minus 1 by 2 is once again 1 by 2. So 25 into root over 1 by 2. Okay, so this will be 1 by root 2, which is nothing but 0.7. So 25 into 0.7 will be around 17.5 radian per second will be the answer. Next question, a cam follower rises by 5 centimeters during 120-degree rotation of the cam that produces uniform acceleration of the follower. The cam is rotating at a uniform angular velocity of 2 radian per second. Then the acceleration of the follower after 1/3 of rotation of the cam during the rise is dash. So here guys, they have clearly stated that the follower motion, the follower is going to move with uniform acceleration. So whether you are calculating the acceleration when the angle is 1/3 of rotation or 2/3 of rotation or half of the rotation, the acceleration is going to be constant. So here if you observe for the displacement diagram will be a second degree parabola and the velocity will be maximum at the midpoint, and velocity will be maximum at the midpoint. Initially it will be 0 and at the end of the stroke, at the end of the forward stroke, it will be once again 0. And if we plot the acceleration diagram, okay, this is displacement, that is y versus theta graph, and acceleration graph if we plot it, it is going to be constant. So for first half it is going, the follower is going to accelerate, that is when we are seeing the increase in velocity from 0 to maximum, and the next half the follower is going to retard, that is when we see the velocity is decreasing from maximum to 0. Okay, so acceleration at all the instances is going to be same. So straightforward problem guys, and you can, I mean it is a recall type of problem. So acceleration formula for the follower is 4h omega square by theta a square it is. Okay, so h is 5 centimeters and theta a is this is 120 degrees, which is 2 pi by 3 radians. Okay, and omega is equal to 2 radian per second square. So if you substitute all these values, that is 4 into 5 into this is omega is 2 square whole divided by 2 pi by 3 whole square it is. And if you solve for this, it will be around 18 point, this answer will be around 18.23 centimeter per second square. Okay. Next question, in a reciprocating engine mechanism, the crank and connecting rod have same length, that is r meters. At a given instant, when the crank makes an angle of 45 degrees with the inner dead center, the crank rotates with an angular velocity of omega radians per second and has an angular acceleration of alpha equal to 2 times of omega square radians per second square. Okay, the acceleration of the piston at the given instant is dash. So now guys, we need to write the displacement equation for the acceleration, that is when we do the approximate analysis of the crank slider mechanism. Okay, so Here, if you observe, at the inner dead center, the piston will be at this position, and let's say this is R and this is also R. Since the crank and connecting rod are of same length, so if this is an angle theta, this will be, let's say, beta. So R sin theta is equal to R sin beta, which is nothing but, from here straight away I can say theta and beta are equal. Okay, so this is the extreme position of the piston, and let's this displacement would be 2 times of R. Okay, and this displacement at this at a given instant, when the crank angle is theta, then this would be R cos theta and R cos theta from this side. So this becomes 2 times of R cos theta it will be. Okay, and this is the displacement of the piston, that is x. So x is equal to 2 times of R into 1 minus cos theta it will be. This will be the displacement of the piston. Now we have got the expression. So now you have to perform the differentiation for this expression. Okay, so for this reason, I mean, this question involves deriving some equation, and after that you need to perform the differentiation. So directly we cannot solve it. Okay, so velocity of piston, that is V is equal to dx by dt is equal to, that is 2 times of R, derivative of 1 is 0 and derivative of cos is minus sign. So minus of minus sign, this becomes plus sin theta into theta dot. Theta dot is nothing but the angular velocity, which is equal to omega. So the expression would be 2R times of omega into sine 45, theta when it is 45 degrees. Okay, so 2 into 1 by root 2. Okay, so this will be root 2 times of R omega. So this is the result up till the velocity analysis. Now we are required to get the expression for the acceleration as well. So if you differentiate this, acceleration of the piston is equal to velocity of piston by dt, that is d of Vp by dt, which is equal to 2 times of R, and here it seems to be 2 variable, guys. Don't miss out here. Here we have 2 variables. One is theta and another one is theta dot. Okay, one is theta and another one is theta dot. So what do we get here? So 2 into R. Okay, so I'll be differentiating this. Let's say theta, sine theta is constant. So this will be sine theta into theta double dot. That will be angular acceleration of the crank, plus, next is, if we differentiate this further, then derivative of sine is cos theta into d theta by dt, which is nothing but theta dot square it will be. Theta dot square it is going to be. Okay, so now acceleration of the piston is equal to 2 times of R into sine 45 and theta double dot, that is 2 omega square plus cos 45 is, cos 45 is 1 by root 2. Okay, so this is, let me write it as cos 45 into omega, it is into omega. Okay, so here it will be acceleration of piston is equal to 2 times of R, and this will be 2 into 1 by root 2, that is 2 by root 2 times of omega square, and this will be plus 1 by root 2 times of omega square it will be, guys. Sorry, I missed here writing here. It's theta dot square, which means it is omega square. It is omega square. Okay. Alright, so this is omega square. So 2 plus 1 by root 2 is 2 by root 2 plus 1 by root 2 is 3 by root 2. 3 by root 2 into 2 is 6 by root 2 times of R omega square times of R omega square meter per second it is. Yeah. So acceleration of the piston will be 6 by root 2 times of R omega square meter square. That is option A will be the answer, guys. Next question, guys, is from the flywheels chapter. A torque provided by an engine is given by T of theta is equal to 14,000 plus 3,500 sine 3 theta, where theta is the angle turned by the crank from the inner dead center. The mean speed of the engine is 200 rpm and it derives a machine that produces a constant resisting torque if the variation of the speed from the mean is not to exceed plus or minus 0.5% and the mass moment of inertia of the flywheel is 150 kg meter square. The maximum angular acceleration of the flywheel is dash. So guys, here it says that the machine is going to resist the or impose the constant torque on the supply. That is, supply is nothing but the engine here. So constant uniform torque means this value is constant and it is not fluctuating with respect to time. So straight away I can claim that this is load torque. This is the torque that is being exerted by the machine on the prime mover, and engine here is the prime mover. Okay, so here that is fluctuation torque is equal to supply torque minus load torque it is. Supply torque minus load torque it is. Okay, so here fluctuation torque is nothing but this fluctuation could be positive or negative, but here this fluctuation is dealt by a device which is flywheel. Okay, in short, this is also the torque of flywheel. This is torque of the flywheel as well. So torque of flywheel, that is, we can write it as torque of flywheel can be written as I of flywheel into alpha of flywheel. Okay, so T supply is 14,000 plus 3,500 sine 3 theta minus the load torque is 14,000 itself. Okay, so this and this will be cancelled. Okay, and the value of I is 150 alpha of flywheel, this is equal to 3,500 sine 3 theta, and they are asking the maximum angular acceleration. The maximum angular acceleration will be when this value is equal to 1. That is, alpha of flywheel is equal to 3,500 divided by 150. So this is 150, that is 52's, 152's is 300, so 150 20's is 3000. So this will be slightly greater than that. So 150 once, and this will be around 150 into 23 or 24. In between that, the value is going to lie. Next question: a uniform slender link of mass m and length L is pivoted at a length from the top, and it is connected as shown in the figure. It oscillates in the vertical plane. The stiffness of linear springs and torsional spring are K1, K2 and Kt. The natural frequency of the system is given by dash. So here guys, the J0, here you can see in the figure J0 is mentioned, which is the inertia of the rod. So as such, they are not at all doing the calculation for the inertia of the rod, which you can find here J0 being repeated in all the terms. So no need to worry about this. And since the arrangement seems to be little complex, so don't insist on calculating the inertia of the rod. Alright, so now we are required to know the natural frequency of this system. So you can see here, this rod is having a mass and it is connected to the point mass m1 and m2 by means of a inextensible rope, which means it is all the masses are having, they are connected. There is no flexible element between these three masses, which means if I give the rotation to the rod, the mass m1 may move towards right side and m2 will move towards left side. Okay, so the position of m1, the displacement caused by the m1 will be L by 3 times of theta, and the displacement caused by the m2 or experienced by the m2 will be 2L by 3 times of theta it will be. Alright, so this will be the displacements. Okay, and now here you are required to get the expression of natural frequency. Alright, so before getting into solving for expression of natural frequency, let us try to draw the free body diagram. So if you draw the free body diagram for this, the free body diagram, let's say that you have given the displacement to this side, okay, I have given the displacement to this side. So here guys, the mass m1 is going to come. So don't assume that, don't say that m1 is going to lose the contact with the ground. Don't assume that. We are giving very slight displacement, okay. Still m1 remains in contact with the ground and m2 is moved towards left side, okay. And once you give the initial displacement, the positions of the masses is going to change, and here guys there will be gravity m1g and there will be gravity due to mass m2, that is m2 times of g. And if you observe here, the m1 and m2, the gravitational force of m1 and m2 will be balanced by the reaction force, So the masses m1 and m2, the weight of m1 and m2 is not at all responsible for the restoration. Do remember that, okay. M1 and m2 is not at all responsible for restoration. So which means that here in option A, B and C, you can see that, you can observe that the mass of the rod is included, but the mass of the blocks seems to be missing. So option D can be eliminated from here. Option D can be eliminated here. So the weight of the rod is going to act downwards like this. It is going to act downward like this, okay. That is mg. So since we have given the clockwise rotation to the rod, the spring force will be opposing that. Let's call this as Fs1. The spring force is going to oppose this. Let's call this as Fs2. And inertia force along with this Fi1, even that is also going to oppose. The inertia force is also going to oppose, that is Fi2. All right. And the mg, this mg will produce, the moment about the hinge will be in counterclockwise, okay, which means the weight of the rod will be supporting restoration, okay. And inertia torque will be also there, that is J naught theta double dot, and along with it we also have restoring torque due to the torsional spring. So all these forces will be present. All right. So now we can write the equation of motion, that is moments about hinge is equal to 0, that is J naught theta double dot plus mass m1 from the hinge, and perpendicular distance is L by 3 whole square, okay, plus m2 perpendicular distance from the hinge, that is 2L by 3 whole square. This will be the net inertia of the system, okay. That is, I need to multiply this with the term theta double dot. Let me write theta double dot as common for the entire thing, theta double dot plus restoring is restoring force, that is Fs1, K, the distance of K from the hinge is L by 3. So we need to multiply the stiffness with the square of perpendicular distance, okay. So that is K1 into L by 3 whole square plus K2 into perpendicular distance from the hinge, that is 2L by 3 whole square, all right. And next is there will be restoring due to the torsional spring, that is Kt times of theta plus mg, capital Mg, that is mass of the rod, even that will be also responsible for restoration, okay. What is the distance? L by 3 from the top. So this will be, I mean the mg location from the hinge will be nothing but L by 2 minus L by 3, which is equal to L by 6, okay. So that is mg into L by 6 times of the perpendicular distance will be from here up till the hinge of the rod will be L by 6 times of sine theta, which is nothing but L by 6 theta. So this is L by 6 theta, and this should be equal to 0. This should be equal to 0. Next question is from the machine design, ball bearings topic. A ball bearing is subjected to a radial load of 10 kilonewtons. So applied load or the equivalent load is 10 kilonewtons, and the dynamic load rating is that is C is equal to 60 kilonewtons. Okay, if the bearing is operating at a speed of 60 revolutions per second, that is speed is 60 rps, or which is nothing but 60 into 60, which will be 3600 rpm. Okay, 3600 rpm is the speed. Okay, and then the average life of the bearing is so many number of hours. So average life they are asking us to calculate. So here the life in million revolutions can be calculated, that is for 90% reliability, that is C by PE raised to the power of 1 by 3 it is. Sorry, it's raised to the power of 3. Okay, it is raised to the power of 3, or K, basically K is 3 for the ball bearing and 10 by 3 in case of roller bearing. So here L10, that is equal to C is 60,000, or 60 by PE is 10 sorry, so the raised to the power of 3. So this is 6 power 3, that is 36 into 6 is 216 million revolutions. 216 million revolutions will be the rating. Okay, now we need to calculate the life in hours, and then from that we need to derive the average life. Okay, so life in hours, that is LH is equal to L10 into 10 power 6 divided by 60 times of n. Okay, so L10 here it is equal to 216 into 10 power 6 whole divided by 60, and speed is equal to 3600. Okay, so this is 10 power 3 in the denominator and 10 power 6 from the numerator, so we will be left out with 10 power 3, so all these zeros will be cancelled, and 36 into 6 is 206, so this will be equal to 1000 hours will be the life of bearing. Okay, that is 1000 hours. Now we are required to calculate the average life of the bearing. So average life, that is L average, is equal to 5 times of L10 it is. Okay, this is an empirical relation. Okay, so here that is 5000 hours will be the average life of the bearing. Okay, straightforward question, guys. Next question, guys, is from the clutches chapter. A single plate clutch transmits a torque of 40 Newton meter in the used condition. So this is for the used condition. If the clutch condition is used, then the 40 Newton meter of the torque is being transmitted. Okay, and the outer radius of the friction lining is 120 mm and the inner radius is of 40 mm. So for the same operating conditions and the applied axial load, the torque capacity of the new clutch, okay, torque capacity of the clutch in its new condition is dash Newton meter. Okay, so here it says that consider the uniform pressure theory for the unused clutch and uniform wear theory for the used clutch. So that is being mentioned over here. So the answer has to be slightly greater than this only. Answer has to be more than this, because we are estimating the torque for the brand new clutch. All right. So for the uniform wear theory, we need to use, that is torque is equal to mu times of W into effective radius. Okay. So effective radius is if we are using wear theory, that is Rho plus Ri by 2, that is wear theory. Okay, and uniform pressure theory, R effective will be equal to, that is 2/3 of Rho cube minus Ri cube divided by Rho square minus Ri square it will be. Alright. So these are the effective radius relations for the uniform pressure theory and uniform wear theory. So the data relating to uniform wear theory is available. So the mu times of W, I mean mu is not given, in even W is not given, so that is equal to the applied torque divided by effective radius effective radius according to uniform wear theory. According to uniform wear theory. So this is the term we have written subject to mu times of W, and we can write uniform pressure theory, that is T is equal to mu times of W can be written as applied torque whole divided by effective radius according to uniform wear theory into, okay, that is mu times of W into effective radius according to uniform pressure theory, okay, that is 2/3 of RO cube minus RI cube divided by RO square minus RI square it is. So this applied torque is 40 divided by effective radius according to uniform wear theory, that is average radius. So diameter, yeah, outer radius is 120. Outer radius is 120. So that is 120 plus the inner radius is 40. So 120 plus 40 divided by 2. This is equal to 160 by 2, which is equal to 80 mm. Okay. So this is 80 into 2/3 of, this is outer radius is 120 is the outer radius, so that is 120 cube minus the inner radius is 40 cube whole divided by 120 square minus 40 square. So this will be equal to 43.34 Newton meter. Okay. So as I said that when you are using the uniform pressure theory, the torque value will be slightly greater than this. Okay. So 43 will be the answer. Next question, guys, is from the variable loading. A rotating shaft is subjected to a transverse load, is simply supported at its end. The length of the shaft is 1000 mm, the diameter is equal to 40 mm, and the transverse load acting exactly at the mid length of the shaft. The ultimate strength is equal to 500 megapascal. The maximum possible transverse load for the life of 5 into 10 power 5 cycles is dash kilonewton. So here, guys, this problem is very beautiful, and here the SN curve data is given to us, and we need to use load life equation, and along with it also we need to relate the amplitude stress with the fatigue strength or endurance strength all. Okay. So load life equation that is given by S is equal to A into n times of A times of n power b, it will be. S is the that is strength of the component, and n is the cycle, that is life of the component. So here, guys, from the graph you can extract this data, that is 0.8 times of SUT, which is ultimate strength, and that is equal to 500 megapascal. So 0.8 into 500 is equal to A into n. What is n value? 10 power 3 cycles. So that is 10 power 3 whole power b it will be. Alright. And the second condition would be at 0.4 times of SUT, that is 0.4 times of 500, we are getting the life as 10 power 7 cycles. So A into 10 power 7 whole power b it will be. Okay. Let's call this as equation 1 and equation 2. So if we divide 1 by 2, this is 0.8 by 0.4, which is equal to 2. This is equal to, that is A and A will get cancelled, and this is 10 power 3 by 10 power 7 is 10 power minus 4 into b it will be. Alright. So from here we need to solve, that is log 2 to the base 10 we are supposed to take it. Log 2 is equal to minus 4 times of b. So log 2 is 0.3010, and divided by 4 it will be that is 0.3 by 4 will be 0.75. Okay, that is minus 0.07525. Okay, approximately. Now we got the b value, and let's substitute the b value in this equation, that is 0.8 into 500 is equal to A into that is n value is 10 power 3 into b value is minus 0.07525. Okay. So from here a will be around 678 approximately, that is 672.71. 672.71 will be the value of A. Now we have got the relationship, that is S is equal to 672.71 into n whole power minus 0.07525. This is the relationship between load life. All right. So now we can relate these two, that is amplitude stress that is sigma amplitude should be less than or equal to this strength value. Okay, let's call this as fatigue strength. Okay, so now this is the here we need to calculate the value of S, okay, at 5 into 10 power 5 cycles. All right, so this is S is equal to 672.71 into, that is life is 5 into 10 power 5 whole power minus 0.07525. So this value, that is fatigue strength value, will be equal to 250 point, it will be 6, yeah, 250.6 megapascal. Okay. So now amplitude stress is given by 32 into amplitude of the amplitude of bending moment divided by pi d cube. It is should be less than or equal to SF. Okay. So here the amplitude of bending moment will be equal to the m amplitude is equal to, bending moment in this case will be load amplitude into L by 4 it is, okay. So now here 32 into load amplitude, that is P, into length is 1000 divided by pi, diameter is 40 mm, whole cube, should be less than or equal to, the strength we have got it as 250.6. So P value should be less than or equal to, the value of P should be below this, that is 250.6 into pi into 40 cube divided by 32 into 1000. This should be the value of P. So P should be less than or equal to, the operating load must be below this value, that is 6.3 kilonewtons approximately will be the answer, guys. Next question, a shaft is simply supported at the ends, separated at a distance of 1500 mm as shown in the figure. It is also subjected to twisting moment of 4.8 kilonewton meter. If the tensile yield strength of the material is 240 megapascal, then which of the following statements is or are correct? So equivalent moment is equal to 48 into 10 power 5 Newton mm, and equivalent twisting moment is equal to 50 into 10 power 5 Newton mm, and standard size according to Rankine theory is 60 and standard size according to Tresca theory is 70 mm. Alright. So here we can calculate the bending moment for this. It is a standard result, that is bending moment is equal to W into AB by L it is. So this distance let us call it as A, and this distance let us call it as B. So straight away you can use this formula. So m into 10 kilonewtons into B is 0.6 into L, that is A is 0.6 minus 1.5, that is 0.9, 0.9 divided by 1.5 meters. Okay. So 0.6 into 0.9 is 0.54, 0.54 into 10 is 54, 54 divided by, this is 0.54, 0.54 into 10 is 5.4, 5.4 divided by 1.5. All right. So 1.53 is 4.5 and there is 0.9 balance. So 0.9, that is 0.9 and divided by 0.5 is 0.6 actually. Okay, 15 6 are 90 it is. So this is 15 3s are 45, okay, and 15 6 are 90, or 15.6 is 9 actually. All right. So this is 3.6 kilonewton meter. Okay, 3.6 kilonewton meter will be the torque. All right. So first bit they are asking us to calculate equivalent bending moment. So equivalent bending moment, that is M equivalent is equal to 1 by 2 times of M plus root over M square plus T square. So this relation will be getting from the maximum normal stress theory. So that is 1 by 2 times of M is 3.6 plus root over 3.6 plus 4.8 whole square, 4.8 whole square, okay, into 1 by 2, or yeah, if you solve for this, the answer would be around, yeah, if you need to perform the conversion. So this will be 48 into 10 power 5 Newton mm it will be, okay. That is equivalent bending moment. So option A is the correct answer. Equivalent twisting moment, that is T equivalent, we get this from the maximum shear stress theory, that is equivalent to root over M square plus T square, and this is root of 3.6 square plus 4.8 square. So this will be equal to approximately 60 into 10 power 5 Newton mm. This will be the equivalent twisting moment. So option B is not going to match. And next they are asking the standard size according to Rankine's theory, that is ultimate strength, yeah, yield strength is given. So option C, that is sigma yt should be greater than or equal to, yield strength should be greater than or equal to, that is 32 m by pi d cube, okay. So that is d should be greater than or equal to, that is 32 into equivalent bending moment. 32 into equivalent bending moment is 48 into 10 power 5, okay, Newton mm, divided by pi into sigma yt. What is sigma yt? It is 240, that is 240 raised to the power of 1 by 3. So if we solve this, we will be getting an answer as 63.3. So this will be definitely, this is 63.3. So the answer, that is the standard size of the shaft according to Rankine theory is 60 mm. So option C is the correct answer. Let me check the number what we are going to get from here. Yeah, it is 58 guys. The calculation seems to be, I mean I missed it. This should be 58. So this is 58.8 mm. So it should be more than this. All right. Next is tau yt. Tau yt should be greater than or equal to, that is 16 equivalent torque divided by pi d cube. So tau yt you can write it as sigma yt by 2 should be greater than or equal to T, that is 16T equivalent divided by pi d cube, okay. So here D is equal to 16 into equivalent torque is 60 into 10 power 5 into 10 power 5 into 2 it will be guys, divided by pi into SYT. What is SYT? It is 240, okay, raised to the power of 1 by 3. So if you solve for this, the value of D will be around 63 or 64. This will be, D should be greater than or equal to 63.4 mm, okay. So option C and D both are correct guys. Option C and D both are correct, and here the choice would be A comma C comma D, okay.
Hello dear students, now let us discuss the thermal engineering solutions for pre-gate exam. Okay, look at the very first question, it is asked like this. The correct relation between gamma equal to Cp by Cv and temperature T, different options are given. Dear friends, remember, as you know, the gamma for any ideal gas is depending on only Cp and Cv. And for ideal gas, Cp and Cv do not depend on the temperature. Therefore, gamma is not depending on not depend on temperature okay. So with that information, look at the option B, gamma is proportional to T naught power 0. As you know, T naught power 0 equal to 1. Of course, anything power on 0 equal to 1 only. Then here gamma is proportional to T naught means what? Gamma is proportional to 1. For eliminating the proportional limit, you need to put the constant gamma equal to a constant, that constant is depending on the type of gas. For monatomic gas, gamma equal to constant, that constant is 1.67 for monatomic gas. Gamma equal to 1.4 for diatomic gas. Gamma equal to 1.33 for triatomic gas. Anyhow, gamma is not at all depending on the temperature. Therefore, option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important question. It is asked like this. A diatomic gas, gamma equal to 1.4, gamma, adiabatic index gamma given 1.4, does 100 joules of work in an isobaric expansion. Isobaric means constant pressure process. So here the process is constant pressure. At constant pressure, work done is given, expansion work is given as 100 joules. Then the heat given to the gas is, what is the heat interaction for the isobaric process? Okay. For that, as you know, the work done for isobaric process equal to P into V2 minus V1. It can be also written as PV2 minus PV1. Since pressure remains constant for the given process, means P1 equal to P2 equal to P. Okay. Then in the place of first P, you can write P2 V2 minus P1 V1. It is also written as PV equal to MRT, MR into T2 minus T1. Okay. Now M equal to what? Product of number of moles and molecular weight into R into T2 minus T1. Okay. N into, as you know, product of molecular weight and gas constant is the universal gas constant, N into Ru into T2 minus T1. So this work is given in the problem as 100 joules. That means this is the one formula for finding the work interaction for isobaric process. In terms of temperature limits also you can write it. Then, as you know, heat transfer Q equal to work done plus change in internal energy. But what is the change in internal energy? du equal to mcv into T2 minus T1. M can be written as, you know, product of number of moles and molecular weight is the mass of the gas, number of moles multiplied by molecular weight into Cv into T2 minus T1. Okay. It is equal to N into mCv equal to molar specific heat at constant volume into T2 minus T1. N into Cv bar equal to Ru by gamma minus 1 into T2 minus T1. Finally, it is N into Ru into T2 minus T1 dividing by gamma minus 1. But what is the NRU T2 minus T1? 100 joules only. It is equal to 100 dividing by gamma. Gamma is given as 1.4. Therefore, gamma minus 1 equal to 0.4. From this, you can get du equal to 100 by 0.4, 250 joules. 250 joules. So here the heat transfer Q equal to what? Heat transfer equal to work done plus du. Work done is 100 joules plus du. du is 250. 250. Simplify this part for getting 350 joules. That is the answer. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, it is most expected problem, most important problem. I can say 5-star problem, most expected problem in the competitive exams. Okay. Similarly, look at the another important problem. It is concept oriented question asking like this. An engine operating between the boiling point and the freezing point of water will be, you know, for water, listen carefully, for water boiling point equal to 100 degrees centigrade, whereas freezing point means ice point 0 degree centigrade. In Kelvin it is 273 Kelvin and it is 373 Kelvin. Okay. Look at the options. Efficiency is more than 27%. Practically, as you know, all practical engines are maintaining efficiency less than Carnot cycle efficiency only. For that, with these two temperature limits, I can decide the Carnot cycle efficiency. Carnot cycle efficiency, everyone knows it. Carnot cycle efficiency 1 minus minimum temperature by maximum temperature. Maximum temperature. It is equal to 1 minus. Here the freezing point is the minimum temperature and boiling point is the maximum temperature. 273 dividing by 373, multiply with 100 for getting in percentage, it gives 26.8 percentage. That is the Carnot cycle efficiency. But practically the heat engine efficiency always less than Carnot cycle efficiency. Carnot cycle efficiency is around 27%, but practical engine efficiency must be less than that 27%. But option A is given. Look at the option A. Efficiency more than 27%. No, right? Option second statement. Efficiency less than the efficiency of the Carnot engine operating between the same temperature limits. Absolutely correct. All practical heat engines are maintaining efficiency less than Carnot cycle efficiency only. Second statement is correct. Efficiency is equal to 27%. No, efficiency less than 27%. Fourth statement correct. Second statement and fourth statement both are correct. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, look at the another important question. It is asking like this. Which of the following statements is or are correct? It is the MSQ type question. MSQ type question. More than one option is the correct answer. Option A, Brayton cycle efficiency is maximum at optimum compression ratio. No, at optimum compression ratio or at optimum pressure ratio, work output is maximum, not efficiency. A maximum efficiency can be decided, right, by equating the maximum efficiency of the Brayton cycle is obtained with the maximum pressure ratio. You know, the critical pressure ratio for Brayton cycle for getting the maximum efficiency is maximum pressure ratio. But at optimum pressure ratio, we cannot get the maximum efficiency, but optimum pressure ratio is for maintaining the maximum network output only. Anyhow, option A, absolutely wrong. Look at the B. For same compression ratio, Brayton cycle efficiency is equal to Otto cycle efficiency. Absolutely correct. Because Otto cycle efficiency equal to what? 1 minus 1 by RC power gamma minus 1. Whereas Brayton cycle efficiency 1 minus 1 by RP power gamma minus 1 by gamma. But for the both Otto cycle and Brayton cycle, the very first process, that is 1 to 2, is isentropic process, reversible adiabatic type isentropic process. For that case, T2 by T1 equal to, I can say RC power gamma minus 1, it is equal to RP power gamma minus 1 by gamma. So these in terms of pressure limits, in terms of volume limits. Anyhow, this quantity and this quantity both are equal to T2 by T1. From this I can say that for same compression ratio, Otto cycle efficiency is equal to Brayton cycle efficiency, or Brayton cycle efficiency equal to Otto cycle efficiency. Option B is absolutely correct. Okay. Similarly, look at the third statement. For same compression ratio and heat input, the Otto cycle efficiency is more than diesel cycle efficiency. Absolutely correct. Dear friends, remember, for the same compression ratio, and heat supplied, and for the same compression ratio, and for the same heat rejection, for these two conditions, remember, Otto cycle efficiency better than diesel cycle efficiency. But for the same maximum pressure condition, and heat supplied condition, and for the same maximum pressure, and maximum temperature condition, in these two conditions, remember, diesel cycle efficiency is better than Otto cycle efficiency. Anyhow, the option C also correct. Okay. Look at the D. Gibbs function remains constant in the evaporation process. Not only in the evaporation process, for all phase change process. For any pure substance, temperature remains constant and pressure also remaining constant. What is the Gibbs function? G equal to H minus Ts. Okay, but H equal to, of course this is written as dg equal to dH minus TDS minus SDT, but dH equal to what? dH equal to 1 minute. Let me write somewhere here, otherwise enthalpy H equal to U plus PV, enthalpy H equal to U plus PV. 1 minute, array, no problem, 1 second, I'll write it. G equal to H minus Ts, but H equal to U plus PV, dH equal to du plus PdV plus VdP, du plus PdV is the del Q plus VdP, del Q equal to TDS plus VdP. Okay. Now the dg equal to what? dg equal to dH minus TDS minus SDT. But dH equal to what? dH equal to TDS plus VdP minus TDS minus SDT, right? The TDS minus TDS cancel. For the phase change process like evaporation, pressure remains constant means dP is 0, temperature remains constant means dt is 0, finally dg equal to 0. dg equal to 0 means G2 minus G1 equal to 0, G2 equal to G1, that means Gibbs function G remains constant for all phase change process like evaporation, condensation, etc. So the fourth statement also correct. Here options are B, C and D. Okay, B, C, D are correct. Understood clearly? Yes. These are very, very important questions. Look at another important question asking like this: which of the following statements is or are correct? Mass flow rate decreases with normal shock waves developed in the diverging part of converging diverging nozzle. Remember, the normal shock waves are developed only in the diverging part, because in the diverging part of the converging diverging nozzle, supersonic flow is found. The supersonic flow only, the normal shock waves are characteristics of the supersonic flow. Therefore, though the normal shock waves are developed in the diverging part of the converging diverging nozzle, mass flow rate cannot be changed, because the throat is the smallest part of the converging diverging nozzle. That smallest part of the converging diverging nozzle, that is throat, will be deciding the maximum mass flow rate. Option A is absolutely wrong. Look at the B. Metastable flow is due to expansion of wet steam in the superheated region. No, the metastable flow is due to expansion of the dry steam in the wet region or superheated steam in the wet region with superheated steam characteristics. B also not correct. Look at the C. Work given by last stage of 4-stage Curtis turbine 2U square. Remember, for any stage Curtis turbine, whether it is 2-stage or 3-stage or 4-stage or 10-stage, work given by the last stage of the Z stage Curtis turbine always equal to 2U square. Option C is absolutely correct. Similarly, the flow separation in D level turbine is due to retardation of the flow. Absolutely correct. You know, in the impulse turbine like D level turbine, the flow velocity is decreasing. That means acceleration is negative. That is called retardation, negative acceleration. Because of that reduction in the flow separation will be happening with the D level turbine. That is a practical reason that D level turbine is maintaining less efficiency compared to reaction turbine. Remember, the D level turbine is coming under impulse turbine. Whether that impulse turbine is water type or gas type or steam type, impulse turbines are always maintaining less efficiency compared to reaction turbines. The reason is, one of the reasons is the flow separation will be happening with the impulse turbines because of the retardation in the flow or deceleration in the flow. Anyhow, option C and D are absolutely correct. Understood clearly? Similarly, look at the another important question. It is asking like this: a real gas within a closed chamber at 27 degrees centigrade, that is the initial temperature, undergoes the cyclic process as shown in the figure. Look at the figure. The gas obeys. It is not ideal gas. This is the real gas equation, one of the real gas equations. PV power 3 equal to RUT. Let me write here. P V power 3 equal to RU into T. That is the gas equation given for real gas. T remains same for the path 1 to 2. For the process 1 to 2, the temperature remains constant. That means indirectly the 1 to 2 process constant temperature process. 1 to 2 process constant temperature process. It means T2 equal to T1. Okay. The net work done in the complete cycle is RU is given 8 joules per mole Kelvin. Look at the pressure given in Pascal and volume is given in meter cube per mole. It means molar specific volume, molar volume, not specific volume. Molar volume is given. You know, for any thermodynamic cycle, net work equal to work for 1 to 2 plus work for 2 to 3 plus work for 3 to 1, because it is completed by 3 process 1 to 2, 2 to 3, 3 to 1. But look at the 3 to 1. 3 to 1 is the constant volume process. For a constant volume process, you know, thermodynamic cyclic process can be possible only with a closed system. The closed system work interaction is PdV. For a constant volume process, since dV equal to 0, work done equal to 0. That means indirectly work for the 3 to 1 process equal to 0. Work for 3 to 1 process equal to 0. Therefore, the network equal to work for 1 to 2 plus work for 2 to 3. But it is given that for the path 1 to 2, the gas is obeying the rule PV power 3 equal to RUT. This is for the process 1 to 2. Now work for 1 to 2. Work for 1 to 2 equal to what? PdV only. From this particular relation, I can write that P equal to 1 minute. Otherwise, here itself I can write it. Should be very careful. P V power 3 equal to RUT. From this P equal to RUT by V cube. It is equal to RUT by V power minus 3. In the place of P, you can write that value. So it is equal to RUT V power minus 3 into dV. So this is a small work interaction. For getting the total work, integrate and apply the limits. Work for 1 to 2 equal to integral 1 to 2, of course RUT constant, V power minus 3 into dV. It is equal to RUT into integral 1 to 2 V power minus 3 dV. So work interaction for 1 to 2 equal to RUT into integral 1 to 2 V power minus 3 dV. Simplify this value. RUT 1 minute. It is RUT. Let us integrate this part. RUT into V power minus 3 plus 1 by minus 3 plus 1. Simple mathematics, school level mathematics. Simplify this part. Ru into T into V power minus 2 divided by minus 2. Apply the limits from 1 to 2. It is Ru by Rut by minus 2 into 1 by V square. 1 by V square. Apply the limits from 1 to 2. It is finally Ru T by minus 2 into 1 by V2 square minus 1 by V1 square. V1 square. You substitute all values. Here this is the V1. V1 equal to 2, V2 equal to 4, right? And substitute all values. Temperature is given. Temperature is 300 Kelvin. 300 Kelvin. Substitute all values for getting the work for 122. My calculator has shown work for 122 is 225 joules. 225 joules. Now work for 223. Work for 223 equal to, that is a constant pressure process. For constant pressure process, work for this process pressure into final volume minus initial volume. Final volume V3 minus V2. P into V3 minus V2. So P is what? P is 10, V3 to, it is 10, 2 minus 4. It is equal to minus 20. It is joules. That is the work for 2 to 3. Then what is the net work? Net work equal to work for 122 plus work for 223. You substitute here for getting the value 205 joules. That is the answer. Okay, 205 joules. Look at the option B. Option B is absolutely correct. Understood clearly? I try to explain the each and every point. Okay. Similarly, look at the another important question asking like this. It is for vapor compression refrigeration system. In an ideal vapor compression refrigeration system, the entropy of the refrigerant is increasing in evaporator is 2 kilojoules per kg Kelvin at 280 Kelvin. That means let us mark the what HS diagram, enthalpy versus TS diagram, otherwise pH diagram. Better to mark the pH diagram, otherwise TS diagram, no problem. You can draw the TS diagram, temperature versus entropy diagram. With the TS coordinate system, this is the saturation dome. Let me mark the pressure limits. Pressure before compression, pressure after compression. Pressure after compression. Let me mark the 4 process connected to vapor compression refrigerant system. 1 to 2 isentropic compression generally, 2 to 3 complete condensation, 3 to 4 throttling process, and 4 to 1 evaporation. In this process, the increase in entropy is ds. That ds is given as 2 kilojoules per kg Kelvin at 280 Kelvin. 280 Kelvin. 1 minute. So this temperature is 280 Kelvin. This ds is 2 kilojoules per kg Kelvin. Then what is the heat interaction H1 minus H4? H1 minus H4 equal TDS only, because that is happening at constant temperature. T is 280 into 2. It is equal to 560 kilojoules per kg. Kilojoules per kg. That is a refrigeration effect. This is nothing but refrigeration effect. Okay. Then the enthalpy of saturated liquid refrigerant after complete condensation is 163.5 kilojoules per kg. That means enthalpy of the refrigerant after complete condensation, that is H3, equal to how much it is given? 163.5. 163.5 kilojoules per kg. Okay. The enthalpy of refrigerant after compression when COP is 2.9. It is given that COP equal to 2.9. Then what is the enthalpy after compression? That is H2 equal to how much? Okay, H2 equal to how much? For that, as you know, during the 3 to 4 process, enthalpy H3 equal to H4, that is equal to 163.5. From this, right, from this particular relation, I can write that H1 equal to H1 equal to 560 plus H4 equal to 560 plus H4 163.5. You simplify this value for getting 723.5 kilojoules per kg. Then what is the COP? COP equal to refrigeration effect by work input. Refrigeration effect is H1 minus H3 divided by work input H2 minus H1. Okay. COP is given 2.9. H1 or otherwise H1 minus H3 directly you can take it. 560, it is 560 divided by H2 unknown value, H1 value. Look at the H1 value 723.5. 723.5. You simplify this value for getting the enthalpy after compression H2 916.6 kilojoules per kg. That is the answer my calculator has shown, 916. Look at the option C. Option C is absolutely correct. Understood clearly? Similarly, completed. I hope all of you clearly understood. Understood or not?
Hello all, welcome to the solution of pre-GATE 2025 Mechanical Engineering. Let's solve first question. A 1 mm diameter electrical wire is covered with 2 mm thick layer of plastic insulation. Okay. So please listen here. There is a wire with insulation. So there is a insulation. This insulation, K insulation is 0.5 watt per meter Kelvin. The wire surrounded by air with the ambient temperature 25 and H is equal to what? 10 watt per meter square Kelvin. The wire temperature is 100. The radius of insulation when the rate of heat dissipation is maximum. Okay, so what is the ask? The radius of insulation when the rate of heat dissipation is maximum. Heat loss is maximum. Heat loss is maximum when radius of insulation is equal to critical radius, and it's a wire, so it's a K insulation by H, so that will be 0.5. What is H? 10. So this will be 0.5 by 10. But if you see here, he asked in mm. So this is in mm, we need to find. So this will be 50 mm. 50 mm. Why 50 mm? Because the heat loss is maximum at a radius R is equal to RC, that is 50 mm. So this is your solution. Let's go to the another question. Two circular surface A and B. Okay, circular is given with the values of emissive epsilon, temperature T, respective view factor are shown in the figure. The heat dissipation only between the surface A and B in kilowatt. Okay, so A and B, A and B. So what he asked, the heat radiation only between surface A and B. So between A and B, how much radiation? As you know, as you can see the figure 1. So let us say this is A and B. We need to calculate from A to B. Okay. Now let us say I consider this is 1 and this is 2. So hope you can understand A1 is equal to A2, that is nothing but the pi r square, and radius is 1 only. So this will be pi, because they are circular, so their areas are pi r square. And what is that? F12, that is 0.172. Okay. Now what is the heat exchange between any two surface? Any two surface, sigma T1 raised to power 4, T2 raised to power 4, 1 minus epsilon 1 by epsilon 1 A1 plus 1 by A1 F12 plus 1 minus epsilon 2 by epsilon 2 A2. Okay. So Q net is equal to 5.67 10 raised to power minus 8. What is T1? 800 raised to power 4 minus 500 raised to power 4 by 1 minus 0.8 by 0.8, this is pi. plus 1 by A1 pi. Shape factor 0.172 plus 1 minus, what is this? Okay, 1 is 0.7. So 1 is 0.7, we will correct here. So here 0.7 we need to write. So this is 0.7, this is 0.7, then 0.8 by 0.8 into pi. So we need to calculate this Q net. Now unit should be in kilowatt. Okay, so quickly I will calculate. So 5.67 into 10 raised to power minus 8 into 800 raised to power 4 minus 4, 500 raised to power 4 upon 1 minus 0.7 upon 0.7 into pi plus 1 by pi 0.172, 1 minus 0.8 into pi. But he asked in kilowatt, so if you divide by this one, so you will get 9.52 kilowatt. This is the solution you will get. This is the solution in kilowatt you will get 9.52. So this is the solution. Let's move to the another question. Stream A with a specific heat capacity 2000 joule per kg Kelvin is cooled from 90 to 45 in concentric double pipe counterflow heat exchanger having heat transfer area 8. The cold stream B specific heat CPB 1000 joule per kg Kelvin enters the heat exchanger at a flow rate 1 kg per second and 40. The overall heat transfer coefficient 250 watt per meter square Kelvin. Assume that the mean driving force is based upon the arithmetic mean temperature difference. Please make sure he said AMTD we are going to use. So AMTD is equal to TA in, TA out by 2 minus TB in plus TB out by 2. Okay, where TI and TI out refer to temperature difference I stream, that is AB, at the inlet and exit. The mass flow rate of the stream A he asked in kg. So what I will do, I will convert this problem into 1 and 2. So A, instead of A I am writing 1, instead of V I am writing 2. Okay. So TH1 is 90 degrees Celsius, TH2 that is 45 degrees Celsius, area 8 meter square. The cold B, okay, first that is CH hot fluid, right? So that is 2000 joule per kg Kelvin. Okay. Specific heat CB, okay. So area is 8 meter, cold stream B. So I am writing B is 2. So TC1 40. Next, mass flow rate 1 kg per second. Overall heat transfer coefficient U 250 watt per meter square Kelvin. Okay, AMTD he asked. AMTD. You see here. So that is TH1 plus TH2. I am writing in my sign convention minus TC1 plus TC2 by 2. TI temperature AB at the inlet and exit, mass flow rate of the A. Okay, so mass flow rate of the hot fluid is asking because A is 1. Okay, hot. Now first thing what we will do, enough information we have. So mass flow rate of 1 we want. Here m dot C is given, Cc also given. So Cc is 1000 joule per kg Kelvin. Okay, so what we will do, first you need to understand AMTD is equal to TH1 90, TH2 45 by 2 minus TC1 40, TC2 we don't know, let it be as it is, by 2. So what you can write, AMTD is equal to, so this will be you can write easily 90 minus 45 minus 40 minus TC2 by 2 we can write. Are you clear? We can write 2 common, 90 minus 45 minus this one. So AMTD is equal to by 2. So 90 minus 45 minus 40, this one. So what we can get, just give me a second. So here it should be 45 plus, it is not minus. So 90 plus 45 minus 40. So here it should be this one. So this is 95, right? So this is 95 minus TC2. So 95 means what? 95 means 47.5 minus 0.5 TC2. Yes, 47.5, 47.5. Okay. This is 90 plus 45 minus 40, 95 minus TC2 by 47.5 minus 0.5 TC2. This is AMTD. This one is AMTD, right? Correct. Now we have here m dot c, cc we have, but we don't have TC2. So what to do? What to do? We can write capital Q is equal to UAAMTD. Okay, UAAMTD. Right. So first of all, you need to understand, we need to calculate mass flow rate, but we don't have TC2. We have TH1, we have TH2. So what we will do here, m dot c cc TC2 minus TC1 I will write here. So U how much? U 250. Area 8. Here we can write this one 47.5 minus 0.5 TC2 is equal to mass flow rate 1 cc 1000, TC2 we don't know, minus TC1 40. So we will get TC2. We will get TC2. Okay. So quickly I will calculate this one. Quickly, just give me a second. Quickly I will calculate 250 into 8. Okay. This should be equal. Okay. This, please try to understand. So okay. So this, if I calculate this one, so I got 67.5 degrees Celsius. So this is TC2 I got. This is TC2 I got. What I did, I put AMTD just like that. 47 minus 0.5, this one. Now TC2 is equal to 67.5. 67.5. Then apply energy balance, m dot h ch, TH1 minus TH2 is equal to m dot c cc, TC2 minus TC1. Okay, so just give me a second. So this is TC1. So once again I will write here. So just give me a second. So I will erase this. Okay, so hope you understand. This is your TC1. TC1. This is the space I need to increase. Okay, done. So this is TC1. Now we got Tc2 67.5. Now you apply energy balance m dot h Ch Th1 minus Th2 is equal to m dot c Cc Tc2 minus Tc1. So m dot h we need to find out. Okay, Ch is 2000, Th1 90 minus 45. M dot C, we have 1, Cc 1000, Tc2 just now we calculate 67.5 minus Tc1 40. So from here you will get m dot h. So quickly I will calculate this. 1000 67.5 minus 40 by 2000 90 minus 45. So if I calculate this one, so you will get 0.305 kg per second. So this is your answer, 0.305 kg per second. This is your answer. Let's start the new question. The one dimensional unsteady state heat conduction, okay, equation in a hollow cylinder with a constant heat source is given Q. If A and B are arbitrary constant, then the steady state solution to the above equation is. So what is the equation? 1 by R, dou by dou R, then R, dou T by dou R plus Q is equal to dou T by dou T. Steady state solution. Steady state solution means this is get cancel out. Then dou by dou R, this is R, dou T by dou R is equal to minus Q by, Q. So this one, so this is Q R. Then integrate this one, dou by dou R, R dou T by dou R minus integration Q R. So this is R dou T by dou R, this is minus Q R square by 2 plus C1. So you can write dou T by dou R is equal to minus QR by 2K plus C1 by R. Then again you integrate dou T by dou R is equal to minus integrate QR by 2K plus C1 by R. So T is equal to minus Q R square by 4K plus C1 natural log of R plus C2. Okay. So I am taking C1 and C2, but examiner replaced by this A and C2 is B. So T is equal to minus Q R square by 4K plus A ln R plus B. This should be your required solution. This should be your required solution. Okay, this is your required solution, minus QR by QR square by 4K plus A ln R plus B. So let's go to the options. Let's go to the option. Here you need to understand minus QR square by 4K plus A ln R plus B. Here it should be minus. So it should be the answer. Minus QR square by 4 plus A ln R plus B. Here there is a typing mistake. Here it should be minus. Okay. That is a solution.
Myself, Madhushekar, faculty of AS Engineering Academy. I am going to discuss here pre-gate questions, especially from material science, metal forming and sheet metal operation. Okay, na? Let us see the question. This is a 1 mark question. Okay. A round disc of 140 mm diameter is to be produced. A round disc of 140 mm diameter is to be produced from a blank of 3.3 mm thickness of a soft stainless steel strip. The ultimate tensile strength of stainless steel is 560 megapascal. Assume ultimate shear strength is 0.7 times tensile strength. The shearing force required in the punching operation. So this question is related to sheet metal operation, punching and blanking. Okay, this is a punching operation. So here in the question, a round disc of 140 mm diameter is to be produced. So it's a blanking operation, a disc they are making. So diameter of the blank is given 140 mm and thickness of sheet is given 3.3 mm. Thickness of sheet is given 3.3 mm and ultimate tensile strength is given 560 megapascal and ultimate shear strength is 0.7 times tensile strength. So punching force they are asking. So see here the formula, it's a basic formula, blanking force or punching force. Okay, it's a blanking operation, that's why I am taking blanking force, otherwise punching force is equal to sheared area of shear into thickness into ultimate shear strength. We should not use tensile strength here. Material is failed by shear, that's why we should use shear strength. So sheared area is pi dt, pi d. So pi dt tau u. Okay. Now here diameter is 140 mm and thickness is 3.3 mm and ultimate shear strength. See, remember tensile strength 560, shear strength is 0.7 times of tensile strength. So shear strength is 0.7 into 560. Here this is in megapascal, otherwise you can say it's a Newton for mm square, that's why I am not converting this in mm into meter, directly mm I am using, because this is Newton for mm square cancel out, you will get in terms of Newton, but answer is there in kilonewton. Now we will see what is the answer we will get. Here I am using a gate calculator, okay na? Here I am using a gate calculator, basic gate calculator. So pi into 140 into 3.3 into 0.7 into 560. So here I got the answer, that is 5.689 into 10 power 5, that is Newton. So we should convert that into kilonewton because answer is given in kilonewton. So that if we convert that into kilonewton, 5.689 into 10 square kilonewton. So from this you will get 568.9 is the answer. So C is the correct answer for this question. It's a very simple basic question. Okay, na? Next. Another question. Annealed copper was cold formed by applying a true strain of 0.8. Given that the strain hardening exponent N is 0.54 and the strain hardening coefficient K is 320 megapascal, then the true stress in megapascal required to initiate a flow in the material during the working, cold working. See, if you understand this question, if you read this question, what is the data given here? True strain is given 0.8, epsilon t 0.8 and strain hardening exponent N is given 0.54 and strain hardening coefficient is given 320 megapascal. Right, here what they are asking, then the true stress required to initiate flow of the material, that is nothing but a flow stress they are asking, true stress they are asking. See, flow stress or otherwise true stress, flow stress or otherwise true stress, YF is equal to K epsilon T power N. They are not asking average flow stress, just they are asking true stress. To initiate the flow of material, how much stress is required, that they are asking. So from this, YF is equal to K, that is 320 into sigma T is 0.8 power 0.54. So I am using engineering calculator here. See here, 320 into 0.8 power 0.54. So here you got the answer, that is 283.67 megapascal. This is the answer. Okay, this is the answer for this question. 283.67 megapascal is the answer, flow stress of the material. Okay, na? Just what I am doing, 320 into 0. Whole power 0.54. This is the answer. Next question. Now see here, which of the following figures schematically represent either Frankel defect or Schottky defect in ionic solids? See, listen, Frankel defect. What is Frankel defect? Frankel defect is nothing but misplacing of an atom from its original position to the interstitial position. Simple language, I will tell you, an atom is moving from its original position to some other interstitial position. Between the atoms it is occupying. Okay. Schottky defect means what? Missing of pair of atoms, means here a cation and anion, both atoms are missing. Now either Frankel defect or Schottky defect. Now you can see here in option A, okay, see, remember the large circles, these are represent anions, the smaller circle represent cations. Now here one atom is missing, one atom is missing, that is anion is missing, this anion is missing, here another atom is missing, that is cation is missing. So this we can say a Schottky defect. Okay, this is a Schottky defect. Now you can see here, this is only anion is missing, this is a vacancy defect. Now here only cation is missing, okay, this is also a vacancy defect. But here cation is moving from its original position to the interstitial position, this is Frankel defect. Okay, it is a multiple selective question. Okay, MSQ. So here A and D both are correct. It is MSQ, multiple selective question. A and D both are correct. Schottky defect, Frankel defect. Okay. Now the last question here. Okay. Now see here, a 38 mm thick plate made of annealed copper is to be reduced to 32 mm thickness in one pass in a rolling operation. So it is a rolling operation. Okay, na? Now see here, it's a rolling operation. I am going to draw this diagram. Maybe you don't have time in GATE exam. Okay, I am just for giving proper data, proper understanding, I am giving the diagram here. Remember, this is initial thickness H0 is given 32 mm, 38 mm, is not 32, 38. Final thickness H1 is given 32 mm. Initial thickness 38 mm, final thickness 32 mm, one pass in rolling. As a result of reduction in thickness, there is a corresponding increase in width of the plate by 3%. So let us consider W1 is equal to 1.03 into W0, 3%, 100 plus 3, 103. Okay, na? So width is increasing 3%, width 3% increasing. The entrance speed of the plate is 16 meters per minute. Entrance speed here. Entrance speed means this speed. So you can say this is V0, entrance speed 16 meters per minute. Entrance speed is 16 meters per minute. If the roll radius is 80 mm and the rotational speed is 30 revolution per minute, remember roll radius is 80 mm and roll speed revolution per minute is 30 30 revolution per minute, RPM, revolution per minute, right. So what they are asking? Then forward slip. Then forward slip. So what is forward slip? What is forward slip? Forward slip is nothing but maximum slip in the leading zone. See, remember this zone is a leading zone. Okay, so maximum slip is occur at exit. Maximum slip is occur at exit. So I am assuming at exit the velocity of the strip is v1. Okay, at neutral plane velocity is vn I am taking. Okay, na? And velocity of roller vr I am taking. Okay. Now forward slip is nothing but slip is nothing but a relative velocity of a strip with respect to the roller. Forward slip is nothing but relative velocity of strip with respect to the roller in the leading zone where it is maximum at exit. So V1 minus VR by VR, relative velocity of strip with respect to the roller is this one, into 100% you can take. Now you can write this one, V1 by VR minus 1 into 100, right. So I want V1 and VR both. I want V1 and VR both. Now listen carefully here. Listen carefully here. How can we find this V1? VR we will get here. VR is equal to, okay, velocity of roller pi dn by 60. Pi dn by 60. Okay, pi into 160 into 30 revolution per minute by 60. How much? Velocity of roller? Pi into 160 into 30 divided by 60. That is 2, sorry, it is, this is in mm, right? I am converting into meter. So you can take this is in 10 power minus 3. Okay, na? You can take this is in 10 power minus 3. So I will get 0.251513 meter per second. Otherwise, the velocity of roller is given in terms of meters per minute. At entry, you can also take velocity at entry this much only. In terms of meters per minute also can take. Okay? Meters per minute also can take. Okay, I will convert that into meters per minute. So I am not going to convert that into 60. Okay, you can take, you multiply with 60. So there is small correction here. Just check. I'll check the formula. 230. Okay. Okay, now. Wait, meters per minute, here you are getting, I am not converting that into seconds, so that directly I am converting directly like this. So I will get the answer 15.07 meters per minute. 15.07 meters per minute. 15.07 meters per minute. Okay, now. Now listen, so I want to calculate the final velocity. How will you calculate the final velocity? Initial velocity I know, I want to calculate the final velocity. So volume flow rate is constant, right? Volume flow rate. So volume flow rate is constant. Okay, volume flow rate is constant. So volume flow rate is constant, that means you can take H naught, okay, H naught V naught, like H naught V naught is equal to H1 V1 W naught and W1, okay. H naught, V naught, H1, V1, W0, right? Now W0, W1 relation we know. I want V1. V1 is equal to H naught, V naught, W naught by H1, W1. Now H naught is 38 into, this is 16 meters per minute into W naught I am directly taking, divided by H1 is 32 into W1 is 1.03 into W naught. W naught cancel. So we'll get V1. How much you'll get, I'll see here. Once again, 38 into 16 divided by 32 into 1.03. 38 into 16 divided by 1.03. Once again, it is 38 into 16 meters per second, 32 mm, okay, 1.03, 1 point, this is mm, this is mm, this is meter, okay, meter per minute, it's not required. Eight. 18.44 meter per minute. Sorry for the disturbance, small confusion. Okay, na? So VR is 15.07, V1 is 18.14. So if I substitute in this equation, V1 is 18.44 divided by 15.07 minus 1 into 100. How much you'll get? How much? 18.44 divided by 15.07 ns minus 1, 2 point, sorry, so 0.22 I got approximately. So 22% approximately, it is 22% you will get, approximately 22% you will get. Okay, na? See, listen carefully. In a simple way, I'll tell you. Here, radius of the roller, speed of the roller is given. From these two, I am calculating velocity of the roller. I am not converting into mm, meter only I am using. That's why 160 convert into meter, 10 power minus 3 meter I am using. So 15.07 meter per minute I got. Next, entry speed is given. Okay, by using this entry speed, initial thickness and final thickness, initial width and final width, I am calculating final velocity V1. So V1 is equal to H naught V naught W naught by H1 W1. By solving this 18.44 I will get. So by using these two, I will get the answer approximately 0.22. Okay, 0.22 is the final answer. 0.22 is the final answer. So answer range must be, they'll give from, answer range must be, they'll give from 21 to 23 or 22 or 21.5 to, okay, 22.5, like that they'll give the range. So this is in terms of percentage if we take like this, or fraction if we take 0.215 to 0.225. So these are the questions of free gate, especially from material science, metal forming and sheet metal operation.
Now see the question here of chapter Advanced Machining Method. The vertices of a triangle are situated at points 15, 30, 25 comma 35 and 5 comma 45. Okay, then guys, here we have to draw the triangle first. The first point is 15 comma 30. Just see here, I want to write the points here. Same way here is also. Okay, then here the first point is 15 comma 30. This is the 15 here. This is the 30. 15 comma 30. This is the first point here. I can write here the point P. Next is 25, 35. 25, 35. This distance I taken 5, 10, 15, 20. Okay. This point as the Q, PQ, and 5 comma 45. This is the 5 and this is the 45. This is, guys, the third point here, 5 comma 45. I can write here the R. Means we have the triangle here, the PQR is the triangle we have. Then I'm drawing the line. This is the PQ. Yes, this is one of the triangle. PQR is one of the triangle here. Okay. If the triangle is first rotated by 10 degree in counterclockwise direction, counterclockwise means anti-clockwise 10 degree, we have to rotate the triangle about the origin point, and then scaled to twice its size, means 2 times of scaling we have to do, means we have to increase the size by 2 times. Then the new coordinates of point 5 comma 45. Point 5 comma 45 means here you can see the last point is there, 5 comma 45. This last point is here. Okay. Then here, guys, firstly the new coordinates of point 5 comma 45. Then firstly, guys, that point, this R point, we have to rotate anti-clockwise by 10 degree first. Then we have to scale this triangle to the twice. Then what are the new coordinates of point 5 comma 45? We have to calculate. Then here I am writing what the matrix for rotation we are writing. The P dash, this is the rotation matrix. P dash is equal to, for rotation I am writing the R into of P. Now instead of P, what is R here, guys? R is the rotation. Guys, this matrix I written the rotation matrix, and we have to calculate P dash. P dash means X dash, Y dash I have to calculate. This rotation matrix is cos theta minus sine of theta. Then here sine theta and cos theta, and here point P means xy. Now P means here we have to write the new coordinates of point 5 comma 45, means we have to write for the point R. Then here I am writing x dash, y dash we have to calculate here, means when the 10 degree counterclockwise rotation, anti-clockwise rotation 10 degree, then here I am writing the cos of 10 minus sine of 10, then here the sine of 10 into cos of 10. Okay, and here the xy. Now xy is 5 comma 45, and 5 and 45 are the x and y points. Yes, now what is the value of, guys, cos 10? The cos 10 is very small value, that is 0.98, and that is 0.98 I am considering the 1. Then, guys, what is the value of sine 10? It is 0.17. Then I am writing here minus 0.17. Then here again 0.17, and here 1, and xy is 545. Okay. Now do the multiplications here. Multiplication here, 5 into 1, that is 5 minus 0.17 into 45. Then next 1 into 5, that is 1 into 5 minus 0.17 into 45, that we completed. Okay, then 0.17 into 5 plus 1 into 45. Okay, then guys, here we can get the answer of x dash y dash is equal to minus 2.65 and here 45.85. Okay, this we got x dash y dash, means here 10-degree rotation. Okay, then counterclockwise rotation we are taking as positive, therefore I taken here plus 10, otherwise I can take minus 10. If it is written the clockwise, then I can take the minus 10. Okay, then here guys, the x dash y dash we got, means here the counterclockwise, the first rotated by 10 degree in a counterclockwise direction about the origin and then scaled to twice its size. Now we have to do the scaling. Now we have to do the scaling of that triangle. Then here I am writing the again p dash is equal to s into p. S into p guys. This s is for scaling. Therefore I am writing now x double dash we have to calculate. X double dash y double dash. The scaling matrix is Sx 0 0 Sy and point P is x dash y dash. Okay. Then here Sx 0 0 Sy. Then scaling is here given the twice its size, means either it is Sx or Sy, it is a twice, means I am writing here 2 0 0 2. Then here the x dash y dash, here the value of x dash we got minus 2.65 minus 2.65 and here 45.85 45.85. Okay, then do the calculation here. 2 into minus 2.65, 0 into 45.85, then 0 into minus 2.65 here, and here the 2 into 45.85. Okay, then here the answer is minus of, what is the answer here? Do the calculation. 5 into 2 0, 1 2 2 4 5, 5.20. Okay, 5.30 here we will get, and here the 45 into 2 90, 91.7, 91.7. Now see the options here. Option C is minus 5.30 and 91.7 here. Means correct answer is option B, minus 6 10. Why such variations we are going to obtain? Here we taken the sin 10 is 0.17. Now instead of that 0.17, if we are writing the 0.2, then we will get the correct answer, that is 6 and minus 6 and 19, we can get the correct answer. Okay, then here the final answer I am writing x double dash y double dash is equal to minus 6 and here 90. This is the final answer. Yes. Now see the next question. Yes, this is the metal casting question. A true centrifugal casting operation is to be performed horizontally to make a copper tube section with outer diameter. Copper tube section with a outer diameter here. Then here I am writing the outer diameter D is equal to 25 centimeter and inner diameter of 22.5 centimeter. If a G factor of 65, G factor of 65 is there, means what is the G factor guys? Here what is the G factor? We have one formula. G factor is centrifugal force on a molten metal to its weight, means to the weight of molten metal. Then centrifugal force is equal to mass into acceleration and weight of molten metal is mass into gravitational acceleration. This formula generally I am giving. Then here you can see that the mass get cancelled. Then here acceleration is equal to what? The g factor into gravitational acceleration. Then this acceleration, that is acceleration is equal to capital G into G. Okay, that we have to use it here. And the G factor is given, that is 65, this value is given, and due to gravity is 9.8, this acceleration due to gravity is given 9.8 are used to cause the tubing. Then the required rotational speed in RPS is, we have to calculate the capital N here in RPS, that is revolution per second. Okay. Then guys, here this acceleration formula I have to write, this acceleration is r omega square is equal to capital G into G. And what is r here? R is, here the diameter is given, no? But radius is always diameter by 2. Then I am writing here the r is diameter by 2 and omega is 2 pi n whole square is equal to capital G into gravitational acceleration. Okay, then put that all the values, easily we will get the answer. Then diameter is 25 centimeter, guys. Now you need to remember here the G is in meter. G is in meter, 9.8. This diameter is in centimeter, we have to convert it into meter here. I am writing here 0.25 meter. Okay, then 2 pi n. N we have to calculate here. Okay, now put all the values, very easy. Then here I am writing the 0.25 divided by 2, 2 pi into n whole square is equal to capital G is 65 here into here 9.8. Now guys, this diameter is in also meter, the G is in also meter. Then here the answer of n directly we will get 11.36 RPS. Okay, and this is the final answer. We have to calculate rotational speed in revolution per second. Okay, here we got the final answer, 11.36 RPS. Now see, this is the question of resistance welding here. Assume that two 1 millimeter thick steel sheets, here the thickness of steel sheets is given, that is 1 millimeter, are being spot welded at a current of 5000 ampere. Here the current is 5000 ampere. And over a current flow time of 0.1 second, that is tau is equal to 0.1 second, by means of electrodes 5 millimeter in diameter, here the diameter is 5 millimeter. Okay, then that electrode has 5 millimeter diameter, then diameter of electrode I written. Assume that the density of steel is 8000 kilogram per meter cube. Here the density of steel, that is 8000 kilogram per meter cube, and the heat required to melt 1 gram of steel about 1400 joule, means heat required per gram 1400 joule per gram, and nugget height is 8 times of 2 sheet thickness. Height of nugget is 0.8 times of 2 sheets. One sheet has a thickness T, the 2 sheet has a thickness 2T. Then the nugget height is 0.8 times of 2 sheets, means 0.8 of 2T. Therefore, the H is equal to, we can write 1.6 into T, right. If the effective resistance in the operation R is equal to 200 micro ohm, that is 200 into 10 raised to minus 6 ohm, then the heat dissipated is, we have to calculate heat dissipation, we have to calculate. Very easy question here. Yeah. Then guys, here the main question, what is the volume of nugget? Here the diameter of electrode is 5 millimeter and it is the same, the diameter of electrode and the diameter of nugget same we are going to consider. In every question we are going to consider the diameter of electrode and diameter of nugget. The diameter of nugget we have, the height of nugget we have, then therefore we have the cylindrical nugget. Now see the solution, I am writing the formula here. Heat generation is equal to heat required plus heat dissipation. Then heat generation formula here, the I square R into tau is equal to heat required, that is mass, into HR per gram, heat required per gram plus of heat dissipation. Then guys, I square R into tau means we have the value of I, we have the R, we have the tau is equal to mass into HR per gram. We have the value of HR per gram, but we don't have the value of mass. Only now we have to calculate the value of mass here. Then here the mass is equal to rho into volume. Okay. Now guys, here the mass, here HR per gram is given, therefore the density also we have to write in gram. Then I am writing the density here, the 8000 into kilogram I am converting into gram, 10 raised to 3 into volume is what, pi by 4 into d square into h. D square into h we can write. Then diameter we have, and h is equal to what, the 1.6t. Then directly I am writing here the what is the diameter here now, 5 millimeter. Guys, that 5 millimeter diameter we have, but I am converting it into meter because density is in kilogram per meter cube. Then diameter here also directly I can write diameter. Directly I am converting and writing 5 millimeter, then I am writing converting into meter, 5 into 10 raised to minus 3, that is volume pi by 4 d square into height is 1.6 into thickness here, the 1 millimeter is thickness, then 1 into 10 raised to minus 3. Yes, very easily we can get here the value of mass. And guys, here the value of mass, if we have to see, the value of mass is equal to 0.25 gram. 0.25 gram. Okay, then here put all the value, the current is 5000. Then I am writing the 5000 square, the R is 200 into 10 raised to minus 6, the tau is 0.1, mass is 0.25 into HR per gram is 1400 plus heat dissipation. Okay, I written all the value correct. Now I is 5000, R is 200, 10 raised to minus 6, tau is 0.1, mass is 0.25 gram, and here is 1400, I written the correct. Then here the heat dissipation is 150 joule. Okay, then heat dissipated in joules we have to write, that is 150 joules. See the question of metal cutting here. In a turning operation with a 60-degree symmetric V tool, then I am drawing here the symmetric V tool. Okay. In a turning operation with a 60-degree symmetric V tool, here you can see the total angle is 60 degree. This angle from here to here, that total angle is 60 degree. This total angle 60 degree. Okay. But here and here it is 30 degree. Okay. And in a turning operation with a 60-degree symmetric V tool and feed, the depth of cut is 0.2 millimeter per revolution and 2 millimeter respectively. Feed and depth of cut, the given guys, the feed and depth of cut, then feed is this is the feed. Here then I am writing the feed is equal to 0.2. Okay, this is the feed. And guys, feed is total 0.2, then this distance is guys 0.1. Then the theoretical peak to valley height we have to calculate. The theoretically peak to valley height of the surface produced, then this RT we have to calculate. This RT we have to calculate. Very easy question. Then tan 30 is equal to, I am writing here tan 30. Opposite side, that is 0.1 divided by adjacent side, that is RT. Then guys, here the RT is equal to 0.1732 millimeter. Yes, but guys, here we have to write the answer in microns, means we have to write the answer in micrometer. Then here I am writing the RT is equal to 173.2 micrometer. Means guys, convert millimeter into micrometer, then multiply by 10 raised to 3 here. Multiply by 10 raised to 3. 173.2 micrometer is the correct answer. Okay, this is the final answer. Yeah, see this question on metal cutting here, very interesting question. In the orthogonal machining operation, the cutting force is given 850 Newton. Cutting force is equal to 850 Newton, and the thrust force Ft is equal to 500 Newton. The chip shear force with the given shear angle, that is phi, I am writing 35 degree. The chip shear force with the given shear angle means here the shear force we have to calculate. Okay. Then how to calculate that shear force, guys? Very easily, according to merchant circle we can calculate. And first I am calculating the resultant. The number of methods are there, some direct formulas are also there, or instead of direct formulas, here we can use the merchant circle, we can draw the merchant circle, and according to that we can also write. Then instead of direct formula I am using the merchant circle method here, that is FC, FT we can put it, 850 square and 500 square we can put it here. Okay, then here guys, the answer of resultant is 986.15 Newton. Okay. Then R we calculated, but shear force here we have to calculate. Then I am writing from merchant circle one formula I am writing here, Ft by Fc is equal to tan of beta minus alpha. Then put here Ft 500, Fc 850 is equal to tan of beta minus alpha. And here the beta minus alpha, that answer around 30, we can get the answer is 30.46. Okay, beta minus alpha we got, but what is our final aim? The shear force. Then according to merchant circle we have to check the formula for shear force. Where is the formula for shear force? Then we have the formula one, R resultant is equal to shear force divided by cos of phi plus beta minus alpha. Then R we calculated here 986.15 is equal to shear force we have to calculate. Then cos of phi, that is shear angle, is 35 plus beta minus alpha is 30.46. Okay, then write the answer of here, the shear force is equal to 409.57 Newton. Yes, yes, options are also available here, that is good thing. 409.57. Correct answer is option B is the correct. You see here the option B, 409.49 is the correct answer. See the question on the machining chapter and this question on the grinding wheel. There is only one formula on grinding wheel, and on that formula this question is here. Grinding wheel with a diameter of 150 millimeter. Here the diameter of grinding wheel is given 150 millimeter. That is, we can write here the 0.15 meter. Is revolving at 3000 rpm. Good, here the n is given 3000 revolutions per minute rpm. The cutting force measured during the grinding operation is 1500 Newton. The cutting force is 1500 Newton with the depth of cut 2 millimeter. Depth of cut here D is 2 millimeter. Here the width of cut is 8 millimeter. And guys, the feeder rate also need to give. If the workpiece is feeding at a rate of 20 meter per minute, the workpiece we are feeding here, then that feeder rate here, the 20 meter per minute. Guys, I don't know whether to convert into millimeter or not. I don't know anything. Just I here converted, but just wait and watch. According to the question, what we have to calculate, we can get what the unit. This question, just see the specific power required for a grinding operation in joule per millimeter cube. Joule is Newton meter, means Newton meter per millimeter cube. Some confusions in the units are there in this question. Then here the specific power required, or also we can say the specific cutting energy. Specific cutting energy we have to calculate. Specific cutting energy we have to calculate here. Okay, then guys, how we can calculate the specific cutting energy? Okay, here guys, the specific cutting energy, one formula is there, that is power divided by MRR. Power divided by material removal rate. Here the power is equal to FC into VC. And what is material removal rate? Here very easy, dWf, d into W into F is the material removal rate. Then what is FC? FC is the cutting force is given. What is the VC? No, we don't have the value of VC, but we can calculate the cutting velocity. Here we can calculate the cutting velocity. Then V is equal to omega into R we can write, then omega is 2 pi n into R is diameter by 2. So guys, here the power we have to take in joule here, because the joule per millimeter cube power is joule. Joule is what? Newton meter. Then here the diameter we need to take in meter. And here the 2 pi into n. What is n? Here the 3000 is given and diameter is 150 millimeter. I am taking 0.15 meter, and 3000 diameter is 0.15 divided by 2. And guys, here the answer for velocity we will get in meter. Either you want in minute or second. Here the feed is in minute, then I am directly writing in minute, I am not converting into second. Here you can see the revolutions, 3000 revolutions per minute. Here I am putting per minute only, I am not converting into second. Then here guys, we got the answer of velocity is 141371 joule per minute. Joule per minute. I am not converting into second. Okay, then I am writing here the specific cutting energy. FC, cutting force is 1500 into VC, 1413.71 divided by dWf. D is 2, W is 8, and F is now the decision 20 meter. Now here the in answer we have to give in millimeter cube. Diameter, width we are taking in millimeter. This F feed also we have to take in millimeter, that is 20 into 10 raised to 3. And here unit will be millimeter cube per minute. And here the power, here the velocity I written wrong. Here the velocity is in meter per minute, not in joule. Here it is meter per minute. Okay, because the diameter we taken in meter, then here it is meter. Here the force is in Newton meter per minute. Here minute get cancelled, Newton meter is joule, joule per millimeter cube. Then here the specific cutting energy 6.62 joule per millimeter cube. Okay, Newton meter is what? Joule. Unit is important in this question. The formula is very easy, calculations are very easy, but here the total, the game of units here, the 6.62 is the correct answer, 6.62. Then the specific power required or specific cutting energy, specific energy required for the grinding operation is 6.62 joule per millimeter cube.
Dear student, I am hoping you have performed very well in pre-gate 2025. Suppose you have done very well, the same tempo you can continue in gate 2025. Suppose you had a mistake in pre-gate 2025, just try to rectify in gate 2025 and make use of this pre-gate for the sake of time management. Same time how you are going to handle all subjects. Okay, you had some experience. Okay, so coming to my subject, IM and OR. So we have a few questions, and of course you have solved almost all questions, I am hoping, and I am going to present the solutions for these questions. The first question, so this question from CPM and PET, and before getting into the details, like just look at this, the probability. When the question is probability, critical path duration first you have to find out. If critical path duration and the due date matching, so without any discussion we can say 50%, because the critical path duration will give 50% probability. If the due date is more than critical path, more than 50%. If the due date is less than critical path, less than 50%. Clear? So how to proceed? First of all, get the critical path duration, because we know this diagram. Critical path is always giving 50% probability of completion. So what is critical path duration? There are 3 critical activities already mentioned. So use this duration, 12, 18, 10, total value how much? 40. So given due date also 40, right? Mu and x matching 40. So what is the probability of completion? Exactly 50%. So probability of completion is equal to 0.5 or 50%. So what was given? Probability is a number between 0 to 1. So we can take 0.5. So PZ is equal to 0.5 is the answer. Right? Next, come into second question. So this question from queuing theory. Total productivity loss per hour. So total productivity loss per hour. So how do you estimate this? Total productivity loss because of breakdown machines per hour. Because per hour mention no LS into productivity loss for one machine per hour. So LS into 1000, right? In the given data, 1000 rupees mentioned. So what is to be calculated? LS you have to calculate. Okay, for LS, what is the formula? LS is equal to rho divided by 1 minus rho, right? So rho we have to estimate. Lambda value given. So what is the lambda value? Lambda is equal to 4 per hour. 4 per hour. Mu is not given. Service rate is not given. Service time was given. Mean service time 10 minutes. So what we do? 1 by 10 into 60. So it is equal to 6 per hour. Lambda 4 per hour, mu 6 per hour. Get the rho value. Rho is equal to lambda by mu 4 by 6, and LS is equal to rho divided by 1 minus rho 4 by 6 divided by 1 minus 4 by 6. It is equal to 2. LS is equal to 2. So you can just substitute here. 2 into 1000. How much? 2000 rupees. So answer is 2000. Total productivity loss is equal to 2000 rupees per hour. So this is regarding queuing theory. And coming to next question. So this question is like 3 variables, like see x1, x2, x3. LP 3 variables and 2 constraints. And what kind of constraints? These are greater than or equal type. So which method we have to use? Big M method. So big M method, of course, it is very laborious and complicated method, and we have to find out Z minimum. It is time consuming. So don't use LP model directly. So what we do? Use dual model. Suppose if we use a dual model, so what is the advantage with a dual model? 3 variables are becoming 3 constraints, am I right? So 3 constraints. And 2 constraints are becoming 2 dual variables. So 3 constraints and 2 dual variables. And what is the best method? Simple graphical method, right? So graphical method, 2 variables means graphical method. So graphical method within 1 or 2 minutes you can manage. So be clever enough. So we have to calculate W maximum. As you know very well, once you get W maximum, Z minimum same only. So W maximum is equal to Z minimum. This is our interest. Z minimum we can estimate using dual model. So W maximum we will get. The W maximum we can equate to Z minimum. Right, now how to convert? First you have to get the standard LP you have to consider. 3 variables and 2 greater than or equal type of constraints. So surplus variables are required. So total how many variables you come across? 5 variables. Minimize Z is equal to, this is actually standard LP. Minimize Z is equal to 70x1 plus 50x2 plus 40x3 plus 0s1 plus 0s2 subjected to first constraint 2x1 plus 2x2. x3 term is missing in this, so 0x3 minus s1 plus 0s2 is equal to 150. 3x1 plus x2 plus 2x3 plus 0s1 minus s2 is equal to 100. Okay, we need 2 dual variables. Name them as y1 and y2. Separate variables, x1 one group, x2 one group, x3 s1 s2. And what about dual? Minimization will become maximization. So dual model W maximum is equal to 150 into y1 plus 100 y2 subjected to first constraint 2 into y1 plus 3 into y2. 2 into y1 plus 3 into y2 less than or equal to how much here? 70. Second constraint 2 into y1 plus y2 less than or equal to 50. Third constraint 0 into y1, no need to write that, 2 into y2. 2 into y2 less than or equal to 40. Next minus y1 less than or equal to 0. This is nothing but y1 greater than or equal to 0. Minus y2 greater than or less than or equal to 0. This implies y2 greater than or equal to 0. After having dual model, graph we can use. So W maximum is our interest. So if we use graph, y1, y2. First constraint is passing through. 2y1 is equal to 70, y1 is equal to 35. 70 by 2. 35 comma 0, 0 comma 70 by 3. And which side you can shade? Towards origin. I am just keeping like this, 0, 0. Next, second constraint, 2 2y1 plus y2 less than or equal to 50, it is passing through 25 comma 0 and 0 comma 50. And which side you can shade towards origin. Third constraint is passing through 0 comma 20. 0 comma 20. And what is the common region? Common region is this is the common region. So O, A, B, C, D. So B and C points we have to find out. So point B, how do you get point B? So point B is nothing but intersection of white color line and this green color. So what about this white color line? This white color line is this 2y1 plus 3y2, right? 2y1 plus 3y2 is equal to 70. So what is the y2 value? y2 is equal to 20, you can substitute. y2 is equal to 20 in the first constraint. So what will happen? 3 into 20. So y1 is equal to 5 we will get. So B point is 5 comma 20. 5 comma 20, just you can check it out. 2 into 5, 10 plus 60, 70. Points is this yellow color line and this white color line. So point C. This 2y1 plus 3y2 is equal to 70. What about yellow color line? 2y1 plus y2 is equal to 50. Just solve this two. 2y2 is equal to 20. y2 is equal to 10. So y2 10 if you get. So what will happen to y1? 20. 20 comma 10. After having the points, get the W value. W at B 5 comma 20. 150 into 5 plus 100 into 20. So how much it is? 750, right? 150 into 5. 150 into 5 plus 100 into 20. 2750. Next, W at C 20 comma 10. 150 into 20 plus 100 into 10. 150 into 20 plus 100 into 10. 4000. So maximum value 4000. No need to take 25 comma 0. So 150 into 25, it is only 150 into 25, 3750. So highest value 4000. So W maximum is equal to, we got, that is Z minimum is equal to 4000. So answer is 4000. Okay, for this question, minimum objective value 4000. Okay, next question from inventory control. So in this question, optimal order quantity we have to find out. It is actually discount model. So CC value was given 20% of unit cost per annum. Get the EOQ first. So whether it is satisfying the range or not, check it out. So get the EOQ value. EOQ is equal to under root of 2D C0 by CC, where D is equal to annual demand, C0 is equal to ordering cost, CC is equal to carrying cost. This formula first we have to use. Let CU is equal to trial 1. It's like a trial and error method we use. Trial 1, let CU is equal to lowest cost 80 rupees. CU is equal to 80 and get the EOQ value at 80 under root 2 into D value how much? 25,000 C naught value in the given data. What is the C naught value? 500. CC value 20%, so 0.2 into 80. So how much it is? 2 into 25,000 into 500 under root 1250. This 1250 unit, check it out. Q value must be 2000 above. But how much you got? 1250. It is invalid. Invalid. It is discarded. So when you are getting invalid value, total cost we have to estimate at Q is equal to 2000 and Cu is equal to 80, because 80 you have failed, no? So total cost at Q is equal to 2000 we have to estimate. So which equation we are going to use? Since we are using ordering quantity Q, so Q by 2 into Cc plus D by Q into C naught plus D into Cu. Okay, total cost at Q is equal to 2000, Cu is equal to 80. So 2000 by 2 into 0.2 into 80 plus 25,000 divided by 2000 into 500 plus 25,000 into 80. So how much it is? 2000.2 into 80, 16,000 plus 25,000 divided by 2000 into 500, 6250 plus 25,000 into 80. 20 lakhs 22,250. So just keep aside this one, you can keep aside and get the evoke at 90 rupees. Next to trial 2. Let Cu is equal to 90 and again we have to find out evoke Q. Evoke Q is equal to 2 into 25,000 into 500 divided by 0.2 into 90. How much it is? 2 into 25,000 into 500 divided by 1178. This is actually valid. Just check it out. 90,000 above. So we got 1178. It is valid. If it is valid, immediately what we can do? Total cost at evoke Q 1178. So Cu is equal to 90. So which equation we are going to use? Under root of 2d C naught Cc plus D into Cu. Square root of 2 into 25,000 into 500 into 0.2 into 90 plus 25,000 into 90. Of course, it is higher value only. Directly we can verify. Into 25,000. $21,213 plus 22,50,000. It is equal to 22,71,213. So where you are getting minimum value at Q is equal to 2000. Ultimately our interest, order quantity and total cost. Okay, when you take Q is equal to 2000, Cu is equal to 80, we got around 20 lakhs 22,250. EOQ 1178. CU is equal to 90. How much you got? 22 lakhs 71,213. Minimum value is 20 lakhs. So the best quantity is 2000 units. So best order quantity is equal to 2000. So from the given options, option D is the right answer, 2000 units. So next question from assignment model, but it's a special case of assignment model. How we can say it is special case? Assignment model is basically for minimization, but the question is maximization. You have to convert this matrix into loss matrix. I can say opportunity loss matrix. What is the highest profit in this? 50 is highest profit, am I right? So 50, and take the unit opportunity loss matrix. Unit opportunity loss matrix you can take. So highest profit 50. So every element you can subtract from 50. So 50 minus 50, 0. 50 minus 40, 10. 50 minus 30, 20. And 50 minus 45, 5. Next 50 minus 35, 15. 28, 22. 45 is there, 5. 10. Next 50 minus 45, 5. 50 minus 32, 18. 50 minus 28, 22. 50 minus 25, 25. 50 minus 40, 10. 21. 15, 2. So this matrix we have to use for assignment. So this matrix, okay, what I am doing, I am taking the highest profit, 50 minus 50, 50 minus 40, 50 minus 30, 50 minus 45, 50 minus 35, okay, 22, okay, 5, and here 50 minus 30, 20, this is 20. 50 minus 45, 5, 50 minus 32, 18, 22, 25, right, 10, 21, correct, 15 and 2. So this matrix I am going to solve by using assignment algorithm, that is Hungarian algorithm, 0, 10, 25, 0, 10, 20, 5. Next 15, 22, 5, 20, 5, 18, 22, 25, 10, 21, 15, 2. Take row minimum, row reduction and column reduction. Row minimum, zero, 10, 20, 5, 10, 17, 0, 15, 0, 13, 17, 20, 8, 19, 13, 0, and take column minimum. 0, 10, 0, 0, 0, 10, 0, 8, 0, 7, 3, 9, 20, 0, 17, 13, 5, 15, 20, 0. So single 0 is going to be the assignment, row or column wise. First row contains 2 zeros. Second row only 1 0, choose this. Third row only 1 0, choose this. This is cancelled. Only 1 0 here, and here it's only 1 0. So finally, in a row, in a column, only 1 0 is taken. This is perfectly all right, and take the combinations. So P2 2. P2 to how much? 40. Q2 3. Q2 3 how much? Q2 3 45. R2 1. R1 combination 45. S4. S4 combination 48. 9 13 8 12 16 17 178. So maximum profit 178. This is the answer. Okay, so that's all about IM and VAR solutions.
Hello everyone, I am Dr. Manikumar, Mathematics faculty in ACE Engineering Academy. Okay, now we are going to discuss some pre-gate questions and solutions in mathematics. We will discuss one by one. You see the first problem. Let F mass, this is a problem related to the calculus. F mass R to R defined by means function at minus 1 within the neighborhood of minus 1 function defined at 1 and less than 1 in left neighborhood of minus 1 and at minus 1 function defined as k minus 2x and in the right neighborhood of 1 function defined as 2x plus 3. X greater than 1 means the right neighborhood only or not? Yes. If f has a local minimum at x is equal to minus 1, one hint given. Okay, local minimum at x is equal to minus 1, then the possible values of k. Actually, see, think logically. Local minimum means generally what one can think like this. I need to apply maxima and minima concept. Okay, you may think like that, but not required. Think logically. So already function defined at minus 1, before minus 1 and after minus 1 also. Use that logic. So limit concept is sufficient here. So you try to understand the question carefully. Suppose x axis, y axis you can take like that. At minus 1. Okay. So local minimum at minus 1 means what is the exact meaning? You can take a small neighborhood around minus 1 within the neighborhood of minus 1. This is a left neighborhood of minus 1, right neighborhood of minus 1. Okay. In left neighborhood of minus 1, less than minus 1 means what is the meaning? In left neighborhood of minus 1 and at minus 1, even at minus 1 also function defined as k minus 2x. Is it? So in right neighborhood of minus 1, function defined as 2x plus 3. Yes, say this. Here I will write. At x is equal to minus 1, exactly at minus 1. What is exact? See, at less than minus 1 and is equal to minus 1 also same function, k minus 2x. So at x is equal to minus 1, what is f of x? F of x is equal to k minus 2x means 2 into minus 1 or not? That is k plus 2. Okay. In left neighborhood of minus 1, what it is? Even in left neighborhood of minus 1 also same function defined, k minus 2x. So L of k, f of x at x is equal to minus 1. So L of f of x means don't confuse, just I am using a notation as, instead of using the left limit, just I am using left side. L means left side neighborhood, f of x value in the left side neighborhood. Okay. At x is equal to minus 1. What it is? That is also, okay, not only at minus 1, even less than minus 1 also same function defined or not? That is also k plus 2. Next, right side of f of x means this is a right limit notation I am using like this. At x is equal to minus 1, what it is in right side neighborhood. So after 1, so at minus 1 and before minus 1 function defined as k minus 2x, but after minus 1, this is minus 1. Actually, a small type error. So after minus 1, function is defined as 2x plus 3. So in right neighborhood, two x plus 3 means I have to substitute 1 there or not? That is 2 into 1 plus 3. Na? 2 into minus 1 plus 3. What it is? So first you write like this. Now you see the question carefully. What is the hint here? If f has a local minimum at -1. So f has a local minimum at -1 means what is the meaning? If within the neighborhood of -1, function must have minimum value at -1. So compare to left neighborhood value and compare to right neighborhood value at -1, value should be less than left neighborhood value and right neighborhood value. So f of x at -1 should be less than f of x in the left neighborhood of 1, in the left neighborhood of -1 and in the right neighborhood of -1. So f of x at -1 value is nothing but k plus 2. Since I am writing the reason. Since f has local minimum, so no need to apply maxima and minima concept. At x is equal to -1. Very clear. See, f has a local minimum at x is equal to -1 means what is the meaning? At -1, f of x value must be less than at -1 L of f of x and R of f of x. Okay, means compared to left neighborhood and right neighborhood, at -1 value of f of x should be less than compared to these two. So minimum at -1, that implies what it is exactly at -1, that is k plus 2. K plus 2 should be either less than or equal, because it should be k plus 2 should be less than or equal to what it is, this one. Compared to left neighborhood and right neighborhood, so value at x is equal to -1 should be less than these two. Clear or not? So that implies k should be less than or equal to -1. K should be less than or equal to -1 means k value is either -1 or less than -1. So what is the question here? Then the possible value of k, not exactly, we don't know. That value may be -1 or less than -1. So one of the possible value is -1. One of the possible value. So -1 is the answer. Clear? All of you followed, I think so. At -1, value should be, so already it has a local minimum. Local minimum means at -1 only that value should be small compared to left and right neighborhood. I used that logic, so without using maxima and minima concept. Okay. Coming to the next problem. If A is n cross n matrix, then which of the following statements is or, this is MSQ question, is or given means we have to verify all the options. Which option is correct, we have to verify. First option. If A is a singular matrix, then one of the eigenvalue of matrix is 0. Obviously correct. Okay. A is a singular means what it is? Determinant is 0. If determinant is 0 means property of eigenvalues, you know, if the determinant is 0, one of the eigenvalues is obviously 0. Directly this is a property, so option A is correct. Properties of eigenvalue. Now coming to second option. If A is a singular matrix, A is a singular means again determinant is 0. Then the system of homogeneous linear equations has infinite number of solutions. This is also correct. Yes, this is system of homogeneous means Ax is equal to 0. Already you know, Ax is equal to 0. This is a system of homogeneous linear equations. Here we have two possible solutions only. No solution case does not exist here. Already you know. So x is equal to 0 means one is unique solution. Second one is infinite number of solutions. Already you know. Okay, unique solution means suppose if the coefficient matrix capital A is a square matrix, determinant should be non-zero. If it is a square matrix, non-zero determinant. Okay, here it is a 0 determinant is 0. So for C, suppose if A is a square matrix, for unique solution, non-zero determinant, for infinite solutions, 0 determinant, already you know. See this. What it is, option B. If A is a singular matrix, means determinant is 0. Then the system of homogeneous linear equations has infinite number of solutions. It is correct. Okay. Next, option C. If A is a singular matrix, singular means again determinant is 0, then the system of non-homogeneous equation has unique solution. This is wrong. non-homogeneous equations also what it is? Ax is equal to b. When unique solution. So generally rank of A is nothing but rank of A not equal to rank of AB. No solution, already we know. Is it? Rank of A is equal to rank of AB. Let it be R, then solution exists. Clear? Even here also, when unique solution, rank is nothing but the number of unknowns. In this case, if the coefficient matrix capital A is a square matrix, det A not equal to 0, unique solution. Okay, right. What is the condition here? Infinite number of solutions means R less than n, infinite number of solutions, you know. Infinite solutions. Clear? But you see here, option C, if A is a singular matrix means zero determinant. A is a singular matrix. Zero, if A is a singular matrix, then the system of non-homogeneous linear equations has unique solution. Wrong. Non-homogeneous system of linear equations, unique solution is compulsory. Okay, if it is a square matrix, determinant should be non-zero. But zero determinant, non-trivial, unique solution is wrong. Next, if A is a non-singular matrix means determinant is non-zero, already you know. Then the system of non-homogeneous linear equations has infinite number of solutions. That is wrong. Okay, so non-zero, determinant non-zero means unique solution. Determinant non-zero means unique solution. But here A is a non-singular means determinant non-zero. Determinant non-zero means system of non-homogeneous equation has unique solution, correct, but infinite given. This is also wrong. So which options are correct finally? A and B are correct here. Options A, comma B are correct. Now coming to the next question. If a fair coin is tossed 20 times, then the variance of the number of heads, this is a simple question in probability, apply binomial distribution, okay. Variance we are asking. So solution. So fair coin is tossed how many times? 20 times. So number of trials n is equal to number of trials n is equal to 20. Is it? Yes. Variance they are asking. See, what is required to variance for the number of heads? P is equal to, okay, P is equal to probability of getting a head. P of probability of head in single trial. In one trial, generally P and Q we are finding for single trial only. Since it is a fair coin, what is the probability of getting a head? That is 1/2 only. So what is Q? Obviously 1 minus 1/2, that is also. So by binomial distribution, what is variance? By binomial distribution, already n, p, q, all three are available. Variance is nothing but variance for the number of heads only they are asking or not. So P and Q, we have we have written P and Q for the number of heads only or not. Variance is equal to NPQ. What is n? 20. P is 1/2. Q is also 1/2. So 5 is the answer. Clear or not? This is numerical question. Answer is 5. Okay. Coming to the next problem, coming to 2 marks questions, these are up to now what we have discussed, they are all 1 marks questions. Now coming to next problem, let M be a 3/3 matrix such that M into X, say this is in a form, this M is a 3/3 matrix. 3 by 3 matrix means how many eigenvalues? 3 eigenvalues. So one hint given here, m into, say this. Generally, you know, if A is, what is the definition, basic definition of eigenvalue and eigenvector? If A into x is equal to lambda into x, then x is an eigenvector and lambda is a corresponding eigenvalue. So this is in a form here, this is in a form, in place of a, m is there. This is nothing but m into x. Say this. I will write here solution. Given, what is given, you try to convert like this, it is possible here. So you can save your time by doing like this. M into minus 2, 1, 0 is equal to 6 minus 3, 0, given or not? This I will write as m into minus 2, 1, 0 is equal to, here take minus 3 common. If I take minus 3 common, minus 2, 1, 0. Now it is in a form Ax is equal to lambda x or not? Say this. A into x, this is a vector, eigenvector, is equal to lambda x. Very clear? So lambda is equal to minus 3 is one of the, this is a 3 by 3 matrix, means total 3 eigenvalues. Among 3 eigenvalues, one of the eigenvalues is minus 3 because it is in a form Ax is equal to lambda x. Here, from this, lambda is equal to minus 3 is one eigenvalue of m. Is it? Now this is the data. From the given data, we have developed up to this. And suppose, and a continuation of the information is there. And suppose that m cube into, again Ax is equal to lambda x form given. M cube into sum, where alpha, beta are real numbers. Then the absolute value of alpha. Say this. Lambda is equal to minus 3 is one of the eigenvalue of m. M eigenvalue I know. We can develop m cube eigenvalue also. Already properties of eigenvalues is there or not? What is the one of the property? If lambda is an eigenvalue, if lambda is an eigenvalue of A, then lambda power k is an eigenvalue of A power k. Is an eigenvalue of A power k. There is one property or not? Like this. A power k. There is one property. Use that property. I know the eigenvalue of m. I know the eigenvalue of m. So using eigenvalue of m, you can develop an eigenvalue of m cube. Okay. So what is the eigenvalue of m cube? Therefore, eigenvalue of m cube is, eigenvalue of m is minus 3. So eigenvalue of m cube is nothing but minus 3 whole cube or not? That is minus 27. Clear? Now you say this. What is given? M cube into, again it is in a form Ax is equal to lambda x, but here lambda is not there. We will try to extract it. Given, what is given? M cube into 1 minus 2 minus 1 by 2, 0 is equal to alpha, beta, gamma. This condition, let it be 1. But I know one of the eigenvalue of m cube is minus 27. According to this condition, since minus 27 is an eigenvalue of m cube, that implies, apply that condition, Ax is equal to lambda x. So m cube into, in place of x, 1 minus 2, 0 is equal to lambda. Lambda is already minus 27 or not? Into minus 1 minus 1 by 2, 0. Shall I write like this? So this is nothing but m cube into 1 minus 1 by 2, 0 is equal to, multiply in right hand side. What it is? 27 Sorry, this is 1 only, minus 1 written by mistake. 20, sorry, minus 27 into, then what it would be? Minus 27, first one. This is 27 by 2, next 0. Let it be 2. Now compare 1 and 2. Say this is given condition is m cube into 1 minus 1 by 2, 0 is equal to alpha, beta, gamma. But using the eigenvalue of m cube, we have got like this m cube into 1 minus 1 by 2, 0 vector. M cube into this vector is equal to minus 27, 27 by 2, 0. Compare these two from 1 and 2. From 1 and 2, what is alpha? Alpha is equal to minus 27. But actual question is what it is? Absolute value of alpha. Absolute value of alpha means you have to give the positive value only or not. Therefore, absolute value of alpha. Take the modulus, that is positive value, 27. Any option is there? Yes. Option C is the correct. Understood exactly. Now coming to the next problem. The percentage error by evaluating integral 0 to 1 x cube plus 2x square plus 3x plus 2 dx using Simpson's one-third rule with 10 subintervals. Okay, this also think logically. Actually, no need to apply Simpson's one-third rule. This is a given function f of x. Here it is a third degree polynomial. So, Simpson's one-third rule gives exact values up to third degree polynomial. So, giving exact value, it gives exact value means error is 0 or not. So, percentage error also obviously 0. What is f of x here? Here f of x is equal to, the function f of x is equal to x cube plus 2x square plus 3x plus 2. This is a third degree polynomial. This is third degree polynomial. So, up to third degree polynomial, not only third degree, it may be second degree or first degree or constant polynomial. Up to third degree polynomial, Simpson's rule gives exact values. Therefore, that implies Simpson's rule of integration, Simpson's one-third rule of integration gives exact value. Gives exact value. So, approximate value and exact value both are same here. Therefore, approximate value is equal to exact value. Now, what is the actual question? Percentage error they asked. Percentage error is equal. Percentage error is equal to modulus of exact value minus approximate value by exact value, is it? Into 100% or not. So, what it is? Exact value and approximate value both are same in sense. Numerator is 0. So, numerator is 0 means total 0 into 100% will get. So, 0% is the final. Understood? So, no need to use Simpson's rule formula. Option A correct. Clear? Now, coming to the next problem. If 300 misprints are distributed randomly throughout a book of 500 pages, then the probability that a given page contains exactly 2 misprints. Apply pause and distribution for it. 300 misprints out of 500 pages. So, the probability of the page has a misprint. Okay, how many, no, so what is that probability? There are 300 misprints. those 300 misprints are overall distributed out of 500 pages. So 300 misprints out of 500 pages, that is P. Solution. Apply P is equal to probability of misprints. In a page. Tell me what it is. That is 300 out of 500. 3 by 5 means 0.6. Say this. Out of, then the probability that a given page contains exactly 2 misprints means how many pages you have selected at random. Given page means only one page you have selected at random. Okay. So number of out of 500 pages, you have selected only one page at random. N is nothing but the number of selected pages. N is equal to number of selected pages. We have selected only one page. That is 1. So first, mean required or not to apply Poisson distribution. By Poisson distribution. Mean mu is equal to NP. That implies mu is equal to 1 into P is nothing but what it is, 0. Mean is 0. Now, the probability that a given page contains exactly 2 misprints. Okay. So, what is our random variable? You just assume a random variable capital X is nothing but the number of misprints. Let you just assume let X is equal to random variable capital X is number of misprints. So, therefore, what is required probability? Number of misprints already have assumed as X. Required probability is exactly 2 misprints. Probability that a given page contains exactly 2 misprints. So, required probability. Required probability. P of X is equal to 2. What is P of X is equal to? Means P of what by Poisson distribution, what is the formula? E power minus mu. Don't confuse. Sometimes in place of, I am taking a notation as mu. In some cases, you can observe it as a lambda also. Notation, you can take lambda also, no issue. E power minus mu into mu power x by x factorial or not. So, e power minus mu means mu is 0.6. Mu power 0.6 whole power x. X is nothing but 2 or not. By 2 fact. Just you can do this calculation. After calculations, the value will be, you will get like this. 0.0988 you will get. Check it. Okay. Option A. Now coming to the next problem. Consider the following statements. See this. Is equal to 0 in right hand side is there in sense this differential equation is homogeneous linear differential equations with variable quotient, that too Cauchy-Euler linear D. This is Cauchy-Euler linear D. Okay. So next this one, this is also is equal to 0 means homogeneous form only, but options will, which of the following options is are correct means again MSQ question. P and Q. Okay, first differential equation is given a notation as P, and the second one is a partial differential equation given a notation as Q. P is a homogeneous differential equation. Yes, obviously correct. P is homogeneous is correct. Okay. Cauchy-Euler, okay, that information not given, but anyhow it is homogeneous. Q is a hyperbolic type partial differential equation. Q is partial differential equation, okay. Is it parabolic or hyperbolic or elliptic? We have to verify. Okay, Q, about Q, what it is? What is it? See, generally, standard form of second degree linear differential, linear PD, you know, that is nothing but what is the standard form? Okay, I will write. What is the standard form of second degree linear PDE? A into dou square U or dou square F by dou square any notation plus B into dou square F by dou X dou Y plus C into dou square F by dou Y square plus D into dou F by dou X plus E into dou F by dou Y plus F into F is equal to G, some standard form. This is a standard form of second degree linear PDE. Okay, this PDE is elliptic. When it is elliptic, already you know, if b square minus 4ac less than 0. It is parabolic when if b square minus 4ac is equal to 0. Clear or not? It is hyperbolic when if b square minus 4ac greater than 0. Verify. So here you compare what is a here in place of a 3x square is there. Okay, now coming to already p information over, coming to q. For q, what is a here? A is equal to 3x square or not? Dou square f by dou x square coefficient. Next, here b is missing. Dou square f by dou x dou y term is not there. So complete dou square f by dou x dou y is not there means total term is missing or not. So b is 0. Is it? Yes. B is 0. What about c? C is nothing but dou square f by dou y square quotient, that is minus 2y square. Minus 2y square. Now compare what is b square minus 4ac, that is 0 minus 4 into 3x square into minus 2y square. That is nothing but what it is? 4 3s are 12, 12 2s 24 minus of minus plus x square y square. Clearly it is greater than 0. Why? Even if xy values or at least one of them may be negative, but x square y square always gives the positive value only. That implies b square minus 4ac greater than 0 means given PDE is what it is? Given PDE is hyperbolic. Hyperbolic. So, which option is correct for Q? Q is a hyperbolic type of partial differential equation. Yes, option B correct. What is option C? P is non-homogeneous differential equation. Wrong. Clearly P is homogeneous, is equal to 0 is there. Okay, next. Q is a parabolic type of partial differential equation. It is wrong. Already hyperbolic we verified or not? Clear? Option A and B both are correct. Clear or not? Coming to the next problem. If f bar is conservative field, then integral C f bar dr bar where C is an ellipse. Very clear. F bar is conservative given means curl f bar is 0 and C is an ellipse. Ellipse is a closed curve. Say this. Given actually direct answer, actually no need integral C, line integral we are asking. Line integral we are asking means you can apply basic line integral means a basic integration concept, or else you can apply Stokes theorem. But here some hints are there here. What it is? F bar is conservative given. Given F bar is conservative. Conservative means what it is? Curl F bar is 0 or not? Curl F bar is 0. And one more. Given curve is a closed curve, that is ellipse. Given curve C is an ellipse. What is that ellipse? Ellipse means that is ellipse x square by 4 plus y square by 9 is equal to 1. Very clear. Curl F bar is 0 and C is a closed curve. Here C is a closed curve. Here C is a closed curve because ellipse is a closed curve or not? Okay. You can apply Stokes theorem. What is Stokes theorem? If C is a closed curve, so if C is, see, what is Stokes theorem statement? C must be a closed curve. To apply Stokes theorem, okay, you can apply Stokes theorem around a closed curve C or not? By Stokes theorem, since C is a closed curve, we can apply Stokes theorem. By Stokes theorem, integral C f bar dr bar is equal to what it is? Curl f bar dot n bar ds or not. Since C is a closed curve, already ellipse. Since C is a closed curve, we are eligible to apply Stokes theorem. So what is curl f bar? That is 0. So that is by Stokes theorem. You can apply Stokes theorem directly. No need to find the line integral. Option is what it is. Clear? This one. Okay, this is a last problem.
Hello friends, let's have a look at the solutions related to general aptitude. So I'll be dealing with the part of numerical ability and logical reasoning part. And this is from English part. This is also English, this is also English. This is from logarithms part, right. If log base 9 into 3 log 2 1 plus log 3, so that is the expression that is being given, that is given as equal to half. Find the value of x. So if you have already learned the basics of this one, it looks like this: logarithm of n base a, if it is equal to x, that gives you n is equal to a power x. If logarithm of n base a is equal to x, then n is equal to a power x. This is the basic that you have to know, like logarithm of 100 base 10 is equal to 2. So this 100 will be equal to 10 square. 10 square is 100. That's the meaning of it. So that is the only logic that we are going to use over here. It is given for 1 mark. Let us see. So now if you are sending this 9 that side, logarithm of base 9 that side, that will give you 3 log base 2 into 1 plus log base 3 into 1 plus 2 log x base 2 is equal to, what will it give you? 9 to the power of 1 by 2. 9 to the power of 1 by 2 means that will be 3. Next, let's try to cancel out this 3 with this 3. I am left with 1. Now send this to that side, then I will be left with 1 plus logarithm of base 3 into 1 plus 2 logarithm of x base 2 is equal to, this 2 is there now, goes that side, will become 2 power 1, that is equal to 2. Throw this one that side, that will give you logarithm of base 3 into 1 plus 2 log x base 2 is equal to, 1 goes that side, 2 minus 1 is 1. Send this 3 that side, that will give you 1 plus 2 log x base 2 is equal to 3 power 1, that is nothing but 3. Send this one that side, that will give you 2 log x base 2 is equal to 3 minus 1, that will be 2. 2 gets cancelled, I am left with 1 over there. Now send this to that side, that will give you x is equal to 2 to the power of 1, that is equal to how much? 2, right? It should be option B. Next, this is related to a reasoning which is based on coding part. It is given that in a certain language, gate is written as LFYJ. Gate is written as LFYJ. So gate is written as LFYJ. So if you look at the codes of these particular letters, G is 7, A is 1, T is 20, E is 5. Similarly, L is 12, F is 6, Y is 25, J is 10. So if you observe the logic, here it is a fixed difference, that is plus 5 is there. So for the letter, if you are adding plus 5, you will get the corresponding letter over there. So for this one, HPCL, you do the same. HPCL. H is 8, P is 16, C is 3, L is 12. So plus 5 means it should be 13, this should be 21, this should be 8, this should be 17. So 13 means M, this 21 means U, this is H, 17 means Q. That should be M, U, H, Q. Hence it has to be option D. This is a very simple one. Let's have a look at 2 marks questions. This is a problem that is asked from geometry and mensuration. So ABCD is a square of sides 2 cm and also CP equal to 2 cm. What is the area of the triangle BCP? To find the area of this triangle BCP, I can simply go ahead like this. Area of the triangle BCP is equal to, from this BQP, from triangle BQP, remove the area of the triangle BQC. Area of the triangle BQC. Now, if you observe it carefully, this BQP area we can easily find because this is 90 degrees over here, because in a particular square, in any square I can say, the diagonals will bisect each other at right angles. That's why this is 90 degrees I can say. If this is 90 degrees, automatically this triangle BQP will become a right angle triangle. Right. Now going ahead with, so area of the triangle BQP is equal to half into product of the sides including right angle, half into product of the sides including right angle. Sides including right angle is BQ into the other one is QP, BQ into QP, minus area of triangle BQC is nothing but, so this is going to be a right isosceles triangle because these two sides are equal. Right isosceles triangle, or you can simply say right angle triangle because you are having a right angle here. Here also that will be area of that right isosceles triangle will be half into product of the sides including right angle I can say. If that is the case, BQ into QC. BQ into QC I can say. Now you need to estimate those values. BQ do you know? We don't know, we need to find. So we know that BD is equal to, this is the diagonal of the square, as the side is S, let us say. If the side is S, diagonal will be root 2 into S or S into root 2. So diagonal will be S into root 2, side is 2, S into root 2, 2 into root 2. And we know that this particular BQ is equal to half of BD. So half of BD means that will become root 2. Half of 2 root 2 gets cancelled, that will become root 2. So here BQ and QC are equal. BQ and QC are equal. And both are equal to what? Root 2. Why? This is the diagonal, this is also diagonal. This is half of diagonal BQ. Similarly, CQ will also be half of this diagonal AC. Right? That's why I'm taking both are equal. Now going ahead with, so half into BQ. BQ value is how much dear? Root 2. QP, you have to be careful here. QP is nothing but QC plus CP. QP is equal to QC plus CP. QC is root 2. CP is 2. Right? So here it will be root 2 plus 2 minus half into root 2 into root 2. Half into root 2 into root 2. Right dear? Going ahead with now. So this gives you take out half here. Half if you take out, this is root 2 into root 2 will give you how much? 2. Plus root 2 into 2 will give you 2 root 2. Minus half has come out, root 2 into root 2 will give you 2. This gives you 2 gets cancelled, that is half of 2 root 2. Finally it will give you how much? Root 2. So area of the triangle will be equal to root 2 square centimeters. Hence it should be option D. Right? Next. This is from blood relations, reasoning part. P, Q, R, S, T and U are members of a family. One couple has parents and their children in the family. P is the son of R and T is the daughter of P. P is the son of R. P is the son of R. P is the son of R. And T is the daughter of P. T is the daughter of P. T is the daughter of P. S is the daughter of U, S is the daughter of U, and U is the mother of T. So U is the mother of T, U is the mother of T means, so it has to be the wife of P. U is the mother of T. And it is also given that S is the daughter of U. S is the daughter of U means U is having a daughter called S. That means this S and T both are the children of the same parents, I can say. These two are married, that means these two are the children of the same parents. I can say T and S are siblings. Now the question is, how is S and T related to each? How is S and T related to each? Both are females and both are siblings. So female siblings are nothing but sisters. Hence it has to be option A. They did not give any information related to Q over here. Next, this is a simple one related to spatial aptitude part. If the paper is folded according to the given dots, then what is the view of the paper according to the given options? So if I am folding based on these dots over here, so as per these dots, if I am folding, so what will appear finally? Right dear? Now going ahead with, if I am folding to this dotted line towards this way, then what will happen? This S and S will together will become 8. So that part you need not even look at. Everywhere you are given 8 only over here. So there is no problem with that. Now going ahead with, when I am folding it this side, what will happen? This heart will coincide with this heart. That means left side only single will be there. So this entire heart will not be visible. And moreover, some people were saying, sir, if I fold it like this, what will happen? No problem. If you are folding it this way, this line has to be below this line. That means line should become right side. So that is not possible over here. This is also not possible. So I am left with only either A or C as my options. If you go ahead with A over here, so what is happening? So if I am folding this over here, this line will merge with this line. So like this, that means you are going to get a line which is which is there at the top of this part as well as at the bottom of this part, which is not happening over here. And moreover, one more hint is, when you are folding this B, when you are folding this one, so B appears like this, whereas B is appearing straight away as it is. That means this is also not possible. So the only possible answer is what? Option C. Straight away we can say that. Now going ahead with the last one from this. The given two pie charts shows the expenditure of two companies, Tej and Sunraj, which are 50 lakhs and 60 lakhs respectively. Now they have given the values in percentages. The question is, what is the difference between the expenditure on employees of company Sunraj to that of company Tej? So Sunraj, what is the money that is being spent on employees? On employees, they have spent 34%. And the total expenditure is 60 lakhs. So 34% of 60 lakhs is spent on employees in company Sunraj. Whereas in Tej, money spent is 28%, that is 28% of 50 lakhs. The question is, what is the difference between these two values? That's all. You just have to take 34% of 60 and 28% of 50. 28% of 50 is nothing but 14 lakhs. This is in lakhs dear. Whereas this one, so 34% of 60, I can see 28% of 50 can be treated as A% of B equal to B% of A. We know that logic. So 28% of 50 can be treated as 50% of 28, that is 14. Similarly, 34% of 60 can be treated as 60% of 34, that is easy to calculate. 60% of 34 is what? 50% of 34 is 17, 10% is 3.4. Together it is how much dear? 20.4. This is 20.4 lakh. Now the question is, what is the difference between these two? 20.4 lakh and 14 lakh. Difference is going to be 6.4 lakh. So I can say that is 6,40,000. Right? So these are the questions that are asked from numerical ability and a logical reasoning part. So English part will be dealt with by English faculty. Thank you.
Hi guys. Let's look at this 1 mark question. I think it is pretty simple. This is a conditional sentence. The moment you look at this one, you understand it's a conditional sentence, and you got a clue here in condition part. Obviously, this is V1, and immediately you should remember the rule. This is type 1 condition. Type 1 condition, if present form of the verb V1 or V1 plus S takes will plus V1, if past form would plus V1, You just have to remember this combination, right? Had plus V3 takes would have plus V3. So you got a clue here and you are looking for will plus V1. Go through the choices. Would help, shall help, will, or shall, can, may, anything is possible. So, no, no. I think pretty straight. Type 1. Fine. Pick out the correct sentence. Again, you have a clue here, guys. What's a clue? It is good to starve. This is a clue. It is better to starve than beg. It is best to starve than. Comparison, comparatives. Positive degree, comparative degree, superlative degree. So, than is a preposition used in comparative degree, right? So, good, better, best, the best. So, obviously answer is this. It is better to starve than beg, comparative degree. Fine. Fill in the blank with an appropriate preposition. Fine. It comes under phrasal verb 2. I thought I would drop dash on you while I was passing. Okay. Now, if you look at this phrasal verbs, guys, verb plus that particle we call preposition or adverb, it has a fixed meaning. Drop in, drop off, drop out, drop off. It's not a phrasal verb. Now, drop out. You might have heard college dropout, like suddenly coming out of a course or discontinuing something, drop out. Drop off. Drop off is like getting into sleep. If you find classes boring, maybe you get dropped off. Now, drop in, to visit someone without any further notice, like I thought I would drop in on you, visit someone. So that's the right word to fill the blank. Fine. Let's look at this one passage. He is asking us to find out the passage is primarily concerned with. He is asking the main point of the passage. Go through this. In the days before the discovery of anesthetics, various methods were used to keep the patient quiet during an operation. One was to knock him senseless. During many operations, several strong assistants held the patient down while the surgeon did his best or worst. On the battlefield, the surgeon might have to amputate a soldier's leg. The stump was then plunged into a bucket of hot liquid tar, which stuck to the wound and stopped the bleeding. No wonder ordinary people hated hospitals and dreaded doctors. Okay. So he is actually talking about some kind of practices which were being made in the past. So why do you think he mentioned all this? To say what? Right? Go through the choices. Primarily concerned with problems of warfare. Warfare he mentioned, but that is only one of the angles, not the whole story. Fine. Then primarily concerned with amputation of limbs. Of course he mentioned this part, but the whole story is not again about amputation of limbs. Then history of medicine and surgery, put a question mark, we'll come back. And primary concern with techniques used to stop bleeding. Now, not only about this, right guys? This is only again some part of that. So obviously he is talking about history of medicine and surgery. Knock him senseless, all these things are supporting us. There are so many things which is talking about the history of medicine and surgery. I think that is the right answer.